Good morning, ladies and gentlemen. For this parallel room 6, I think we already have almost our presenters, and we already have our keynote speaker, Professor Joko. So please, Dr. Saptadi, I think we can continue.
Okay, thank you, Ms. Diahayu. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Hopefully, we are always in a good health for today. After we join the plenary room for the keynote speech presentation, now we are in the break room for parallel session 6. Today we are going to be having to invite speaker for 14 presentation in this parallel session. I'm Saptadi Darmawan from Research Center for Biomass and Bioproduct, National Research and Innovation Agency. Will be taking my place as a moderator in this parallel session that focuses on biopolymer. I would like thanks to the invited speaker who joined this symposium. Today, the wonderful presenter in this session will be first the speaker, Prof. Joko Santoso from IPB University, and second, Dr. Amalina Amir from University Technology Mara, Malaysia. Okay, we invite you all to give a round of applause to the invited speaker. Before we start our session, I would like to gently remind all invited speaker and presenter that we will divide our session into 4 parts. First is invited speaker speech, and 3 other for paper presentation. And each part will possess Q&A in the end of session. So please stay on your session to answer any question for any presenter until the end of our session. And we will have a photo session in the end of our session, so please stay tuned until the end. I would remind you that we would love to deliver interactive session between you and the speakers. Therefore, for the presenter, we invite you to turn on camera on one start, including playing your video presentation and beginning the question and answer session. For the participant, we also welcome you to do so. However, if you are shy to turn your computer on, you may use the raise hand button on your screen to deliver your question. Okay, for now, I would like to invite our first speaker, Professor Joko Santoso. We invite you all to give a round of applause for Joko, because of Joko is able to join us today and going to deliver a live lecture. Okay, this is the short bio of Joko. Prof. Joko Santoso completed his bachelor degree at IPB University, Faculty of Fisheries and Marine Science in 1990. His PhD was assigned at Tokyo University Fisheries Graduate School for Fisheries Science in the field of food and technology, Japan. He is a professor at Faculty of Fisheries and Marine Science and IPB University. Recent study is to utilize the seaweed and seaweed waste processing, namely cellulose, for the biofuel and biogas as renewable energy. Okay, Professor Joko, time is yours. You have 25-minute presentation, but hopefully it will be earlier. Okay, please, Prof. Joko.
Okay, thank you very much, Mr. Chairman. I'm Joko Santos from IPB University. Thank you for the committee to giving opportunity to share our small research related how to utilize the seaweeds. Okay, I use the share screen. Okay, it's clear?
Yeah, it's clear.
Okay, my title in this sharing experience about the tropical seaweed as source of cellulose, opportunity, and also challenges. Okay, my topic will divide it into three points. The first is the importance of tropical seaweeds for the coastal community in our country. And second one is utilization of tropical seaweeds, integrated seaweed processing technology, including how to utilize the cellulose material. And the final one is the opportunity and also the challenges. Okay, because today is a special day for us, for me, especially for the Muslim people. So we can read about the Holy Quran. Holy Quran said that, but this Quran is a seed of a clear revelations preserved in the heart of those gifted with knowledge, and none denies our revelation except the stubborn wrongdoers. It's meaning that when we have do some research and we find a new thing, meaning that we increase our iman. And also in Holy Quran state about the sea, ocean, mentioned about the 32 version, 32 ayat, and the land about the 13 ayat, and the total is 45. So if they compare a sea about 75% and land about 29% is the real condition in our Earth planet. And also in Quran also said about the two water cannot mix because it's either have the labyrinth in the Surat Ar-Rahman and also in the Surat Al-Furqan. So ladies and gentlemen, talking about ocean, about sea is mystery. And sea provide the fish and plants as a foodstuff. And also ships traveling use the ocean. And also sea provide the ornamental to wear, namely a gold or pearl. And we, as a human, should to utilize optimally. And the final goal is the grateful thanks to the Allah Subhanahu wa Ta'ala. And also human authority on the earth is a Khalifah, the meaning a representative of God, that the duty to utilize and to maintain and take care earth to make better. Okay, so the importance of seaweed for the coastal community in Indonesia. This picture shows the activities of the farmer in the coastal area in our country. This checking the monitoring in the soil monitoring is the harvesting, and this is drying using the hanging method. This is also a picture about the culture seaweed activities. Same too with the previous photos. The harvesting methodology and sustainable development goals mean that we to utilize and also thinking about the maintain and also take care for next generation. Al-Quran already said about 15 centuries ago relating to the SDGs, and now each country have to program related to the SDGs contain 70 pillars. And seaweed for the beneficial of human being and for the next generation. So for Indonesian, the coastal natural resources, seaweed is the coastal natural resources that have high economic value, become the export commodity. And based on the Siboga expedition, we have the around 500 species and around 55 already had utilized. But in the recent time, we reported around 900 species. And traditionally, the seaweed utilized by foodstuff called named the sea vegetable. Okay, in case of the seaweed culture, some advantages we have The first is explore marketing opportunities as always open, and restricting a quote for seaweed straight, no restriction. And cultivation method is simple, making easy to be mastered. Cultivation cycle is relatively short, so quick to give the advantage, and relative low capital requirement until no an irreplaceable commodity because no synthetic product. And the last one is labor intensive business, so it can create the job. This is a cycle of seaweed cultivation from the preparing and cultivating, nurturing, harvesting, and then the drying. Okay, the best place for the seaweed growing, tropical seaweed, is located in 10-degree latitude south and also 10-degree north latitude. This is the area that seaweed can growing well. And the position of our country related to the coral triangle. This is the coral triangle that how to say, the very best area to cultivate the seaweed, namely in the Capapicus alvarezi or Echema cottoni. And talking about the coral triangle, 71% is allocated in the coral triangle, and we have the percentage very huge, about the 65% is located in our country, so that seaweeds become the important commodity for our country. And also, if we mapping in the west, central, and also east Indonesian water, in case of East Indonesian water, the production can increase many times, as well as the central Indonesian waters. This photo shows the seaweed Capapicus, the produce of the kerajinan. This is activities of housewife to help the husband to prepare of the seaweed before cultivation. This is acrophyte, the meaning of seaweed that can produce the agar. This is also the Gracilaria, is cultivated in the brackish water by polyculture with the milkfish or shrimp. This is alginophyte, the source of alginate. However, in case of alginophyte seaweed, still white until now there is no culture yet. This is also the many kind of brown seaweed that can produce the alginate. This is green seaweed, ulva, silitas, that produce some of polysaccharide, namely ulvan. Okay, the second talking I would like to share about how to utilize the tropical seaweed with integrated seaweed processing technology. So in seaweed, there are many useful compounds found in seaweed. From the sulfated polysaccharide, that main compound, and also pigment, mineral, sulfide, alginic, cellulose, fucoidan, both of primary and also secondary metabolite. This is a composition of seaweed from Rhodophyceae, from red seaweed, mainly a content of cellulose, and also carrageenan and kappa-carrageenan as a polysaccharide, and also pigment, picocyanin, and also picoerythrin. So utilization of seaweed for human being based on history, and also technology, we can divide to 5 generations. The first is seaweed as a foodstuff, and followed by seaweed as a picocolloid. We extract the picocolloid, carrageenan, fucoidan, as well as the agar. And the third generation is natural product, meaning the active compound. So many active compound can found from seaweed, especially seaweed that are grown in the tropical area. And the fourth generation is the bioenergy. We utilize the cellulose and the biomass to be bioethanol as well as the biogas. And the last but not least, in the recent years, the biomaterial, especially from the biomedicine, the drug delivery, has many research. So in case of the seaweed as food stuff in our country, the local people live in the coastal already utilize seaweed as a sea vegetable in the Maluku, Takalar, South Sulawesi, and also local people already utilize seaweed as a thalassotherapy, anti-helminthes, for example, and also this is a caviar vegetable, not from the sturgeon fish, but we can try to have like a caviar, but from the grape seaweed. Talking about the seaweed as food, seaweed as foodstuff, the East Asian country, Japan, Korea, as well as China. So many marketable seaweed can found in the supermarket. Wakame, kombu, hijiki, and nori is the edible seaweed that can find easily, as well as in our supermarket and our convenience store. Alfamart, Indomaret also provide this kind of nori. So some of to increase our fish seaweed consumption, we try to add in some food. For example, add it with the akasam to make a jelly probiotic beverage, and also we insert to the tempe, soybean fermented, to make a seaweed tempe. This is photos about the adding of seaweed in the tempe. And also in the case of ulva, green seaweed, we try to make nori, because nori only grows in the sub temperate area, so that cannot found in Indonesia. So we try to make like nori or nori imitation using ulva, and the flavor we can use of the fish boil water. And this is chemical component, some tropical seaweed, the most compound mineral become the major component. And this is also some of mineral compound we can find both of macro and also micro mineral. So one of the YouTube we also can find in seaweed. This is a dilemma. If we have the resources, the huge resources, but some cultures still found in our country, is also noticing problem. This is a content of some dietary fiber, total insoluble and also soluble dietary fiber, including the celulosa in this compound. So talking about dietary fiber, this is a definition of dietary fiber that constituent from plant that are resistant to digest by human gastrointestinal enzyme. And some advantages eating the dietary fiber, for example, can prevent the colon cancer, increase fecal bulk, yeah, and also can decrease the plasma cholesterol. This is enterohepatic cycle, the meaning that the seaweed, if we eat the seaweed, the dietary fiber, we can when the seaweed can bind cholesterol, both of endogenous cholesterol produced by liver and also from the dietary cholesterol binding and to release by fecal. So, in case of the biopolymer of the tropical fucocolid, we can divide into three groups: carcinophage, the produced from the Echoma sponisum, Echoma cottoni, and acrophyte, produced by Caridium and Crassialaria. Carcinophage and acrophyte belongs to the red algae, and our country already culture well. In case of alginophyte, just I mentioned that a seaweed of alginophyte still wild, and no industry until now. The carcinophage in seaweed is found in between the cellulose part. In case of basal, carcinophage content higher in compared to the apical. In case of tropical seaweed in our country, we have hot times a year and harvesting. So the seaweeds in our country can grow well, and there is no seasonal variation, almost no seasonal variation. This is a weekly variation. So in case of seaweed, 45 days, 55 days is optimum produce the carcinophage and as well as the biomass. This is photos in compare fresh seaweed to be dried seaweed form. This carcinophage belong to three type of carcinophage: kappa, iota, and lambda, depend on the number of sulfate group and also the position. This is how to extract the carcinophage using the conventional method by alkali method, and the other one is with the engineering process. We modify it to be a carcinophage fiber. This is some of information related to the type of seaweed and also the concentration of sodium hydroxide for extraction of the carcinophage. And we can see that the cal strength increase related to the number of galactose. I mean, meaning the 3,6 anhydrogalactose. The cal strength in line with this concentration, and opposite with the concentration of sulfate group. So this slide shows the engineering of carcinophage to make a new derivative with the special purpose by carboxymethylated, acylated, and some others reaction to be a new material with have the biological function, for example, anti-cancer, anti-obesity, antimicrobial, and antiviral. This is also a carboxymethyl kappa carcinophage modified from the kappa carcinophage, and this slide provide that proof that this derivative have the antioxidant activity as well as the antibacterial activity. Alginate belongs to the meaning the produce from the brown seaweed. The characteristics also same with the carcinophage, but the monomer is different. The monomer of alginate is manoric and also chloronic. So this cross section of the brown seaweed, where is the position of the alginate mixed complex with the calcium by X-box junction, and other material we can find the cellulose, sulfate, protein, and so on. This is the principle how to extract alginate using the alkali, and basically the process of extraction divide to to group a calcification process using calcium and acidification process using hydrochloric acid. It's all same. This subtropical seaweed, like this, the photos, and this flow chart how to make alginic acid and to make derivative, namely the sodium, calcium, and others. And the other one is to make derivative also, to make propylene glycol alginate using esterification process by propylene oxide to make alginate derivative if soluble in the temperature, room temperature. Is some factor that affect the extraction of method, temperature, time of extraction, alkali type, and also concentration as well as the pre-treatment. This is by
Recording in progress.
Process, we can change alginate to be propylene glycol alginate. This is a photo of alginate, and it's the salt alginate, ammonium, potassium, and also sodium alginate. It's a box junction, just I mentioned, so that's why the gel of alginate is tough in compared to others. Like this, if we compare to gelatin, carrageenan, agar, and alginate, we treat it with the microwave oven, 1 minute, 500 watt. You can see that alginate still stable. So alginate right now also used to be biomaterial, bone dressing, tissue engineering, drug delivery in the composite form, the fiber, bead, hydrogel, and printed is a challenge for us to research more related the biomedical application. Is agar like this, the monomer and also polymer. This some of seaweed, Callidium, Callidiopsis, also Callidium corneum, can extract this red seaweed to be agar. Is basically how to extract by alkali, and some use the mechanical treatment by ultrasonic, for example, also by microwave. We can also use this equipment. This is the benefit of eating of seaweed, including the sertas, maybe to reduce the oxidative process, yeah, promote longevity, strong bone, and so on. So another compound also found in seaweed is phenolic compound. This metabolic secondary. That's why seaweed grows in tropical country that suffer on the hot, the strong ultraviolet can still grow well, and we predict that the seaweed contains some compound active, for example, the phenol. Also, the phenol become the potential functional of the ingredient. This is just
recording stopped.
The polyphenol. For example, this phenol and the derivative tannin and also polyphenol. This is the hydrolyzable tannin, and another one is catechin and some others polyphenol. Is a flavonoid based condensed tannin.
I'm sorry, Prof. Joko.
Yeah.
You have 2 minutes again. For
okay, I will skip this. So, again, for the bioenergy, it's very nice area. We try to already research to change to make ethanol and also a biogas, and this is principally to process bioethanol, hydrolysis, fermentation, and purification, and also to make biogas using the hydrolysis, acidokinesis, also metagenesis. This is the benefit of seaweed comparison to the terrestrial plant. for the average material and also the potential volume, the ratio and, from the 3 until the 23 times, meaning the seaweed is very high, how to say, high percentage to become the ethanol. There's some research about that. And also this is biogas from seaweed that I already conduct. Also some this. Also the comparison between ulva lactusa and also banana stem waste. That means that ulva can produce the flammability test with the higher in compared to banana stem waste. Okay, the last one is the opportunity challenges is one of the important thing. The biorefinery seaweed product for the future. The keyword is renewable, degradable, and recyclable is the more important thing for extraction product, fertilization, fuel, feed product, and so on. This is a problem to alga bio. This is the pigment we can extract it from the seaweed. This is extraction. Not only use the conventional method, but we can use the new method extraction with the culinary processing. This is integrated seaweed, bioactive compound. We can extract for the sensitive compound by buffer, for example, and the remaining material we can extract the carrageenan, and the byproduct, namely cellulose, we can use as a sort of bioethanol. So integrated processing is necessary. So this is like this, the biorefinery. It's also same. Yeah, this cellulose can produce the hemicellulose and also other material that can convert to ethanol. It's also same. The agar, this is the waste, we can use the ethanol as well as the other material. I think this is same. Yeah. So the challenges is for the purposes related to the health, we need research more. We calculate biological function, processing biorefinery, and also specialized compound with the high press should be more attention. This is a pentahelix collaboration model should be pulled until from now. So sometimes we have the phase like this. Yeah, every group you do something, but if we discuss some problem like this, this is we face some problem. So the SIFUCA is our known condition to shifting the fragile to the agile. It's not the strongest of the species that survive, not the most intelligent, but the adaptable to change is the survive creators. I think this all of my presentation. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Prof. Santosa, for your excellent talk. We are sorry, Prof, because you are the limited time.
Yeah, sorry juga.
Okay, for the second invited speaker, Dr. Amalina Amir from University Teknologi Mara, Malaysia. We are sorry. We are so very happy because Dr. Amelia is able to join this today in this symposium. Dr. Amir?
Yeah, thank you. But I think the video will be played, and then I will answer the question and answer.
Okay. Thank you. Nice to meet you, Dr.
Nice to meet you, Prof.
Yeah. This is the IP, please. So the short bio. Okay. Dr. Amalina Amin, born and raised in Malaysia. Dr. Amalina now head of Innovative Electromobility Research at University Teknologi Mara, UPR. She has graduated in New Material and Mechanical Engineering from University College London. Then she continued postdoctoral research at the same place. She now focusing her research in biomaterial and nanocomposite. She also ventured into drug delivery system that she learned from UCL. She is won several prestigious international awards in British Invention Show and Seoul International Invention Fair. Dr. Amalina Amir will talk about recent advance in biocomposite and biofiber. Okay, this also the video recorded presentation is in IT.
Hi everyone. I'm Amalina Amir from University Technology Mara, UITM Malaysia. Currently, I'm the head of electromobility research in UITM. I'm also now focusing my research in biomaterials and nanocomposites. I'm also ventured into drug delivery system that I've learned in University College London during my PhD research. Not only that, I also involved in structural analysis of the automotive chassis design. I hope that we could collaborate after this if you're interested in any area of my research. The growing awareness of socio-economic and environment issues and the high percentage of petroleum resources consumed and new environmental regulations due to environmental and sustainability concern, the advancement of biocomposites have resulted in tremendous breakthrough in green materials in this century. Their primary goal is to replace current synthetic petroleum-based composites with the natural resources. Materials derived from non-renewable petroleum-based resources are hazardous and expensive to produce. On the other hand, biocomposites derived from natural sources are biodegradable, recyclable, non-abrasive, and compostable, and have properties comparable to synthetic fiber composites. Nature fibers are low cost, lightweight, biodegradable, renewable, and environmental friendly. They are alternative to synthetic fibers like glass and carbon fiber. The long-term viability of natural-based fiber composite material has led to increased use in various production industries. However, the manufacturing process of natural fiber-based biocomposites still in plague with some difficulties, such as poor adhesive property, moisture absorption, poor fire resistance, low impact strength, and low durability. Not only that, due to the hydrophilicity of the biofibers and the hydrophobicity of the polymers, this is a very challenging task. But chemical and surface treatment, on the other hand, are superior way to solve this problem. So biofiber composite is hybridized with another biofiber, and the mechanical qualities are not superior to when the composite is hybridized with synthetic fiber. So this will create good interfacial bonding between biofibers and polymers. So this is biocomposite electric car. So biofibers is a material that derive from biological origins such as crops, plants, and other renewable agriculture and forestry materials. And biocomposites, bioresin, derived to replace bio-based polymer with starch, vegetable oils, and protein. Composite based on cement, use new binders such as geopolymers and recycle aggregators. So the introduction of renewable and recycled energy decreases petrochemicals and mineral and eliminates the loss of natural energy. So a green economy is characterized in terms of low carbon, productive capital, and social inclusion. In the green economy, public and private investment drive growth and incomes through these business practices, infrastructures, and assets that minimize carbon emissions and pollutions, boost energy in resource quality, and avoid biodiversity loss and ecosystem services. Land pollution occurred due to the landfill of the synthetic fiber reinforced composites upon completion of their life cycle. Usage of biodegradable resin with plant fibers has been current trend as they render biodegradable, eco-friendly, and they can be easily disposed of upon completion of their life cycle. Here we have several types of biofibers, which is wood and non-wood. So from wood, we have soft woods and hardwoods. And for non-wood, we have seed, fruit, bast, leaf, stalk, and grass skin. We have several plants that are classified into non-wood, such as pineapple, cotton, rice, bamboo, and so on. And we have soft and hardwoods for the wooden biofiber. Synthetics is from petrochemical products and biotechnological products, and the natural origin from biomass products and microorganism products. So the combination of the fibers and also the polymers has to be chosen wisely because of they have some characteristic that we have to modify. Sometimes the wrong combination will lead into weak properties of the outcome fibers. But with the combination, the right combination will give biofibers equally. The strength is equally to the synthetic fibers. So as I told you before, we have to do some chemical structure to improve the properties of the natural fibers. The major benefits provided by biofiber-based polymer composites are lightweight and biodegradable, which are also the main reasons for their popularity among producers and consumers. A disturbing phenomenon plaguing most parts of the world is the plastic waste. Governments around the world are enforcing strict limits on the use of plastics and encouraging eco-friendly alternatives to resolve this issue. This is sure to help the market considerably over the forecast period. The business is likely to face such obstacles considering different advantages over the next years. Technological advances in production processes such as compressing molding, injection molding, and extrusion are likely to have impact current market trends. Biofiber-based polymer composites are experiencing comprehensive growth with good prospect in the automotive and construction industries. Bast fibers such as hemp, canal, flax are preferred for automotive applications. On the other hand, wood plastic composites is a material of choice for construction industries. Looking at the development of the current trends to remain as the largest market for biofiber-based polymer composite due to the high acceptance level of environmental friendly, composite materials by automotive industries, government agencies, and growth in small-scale environmental friendly industries. The improvement in materials performance will drive the growth of biofiber-based polymer composite. Biofiber-based polymer composites are new in electrical, electronic, and sporting segments. However, it has potential to capture a good market share segments. The size of the global markets for bio-based fiber composites was estimated at 4.46 billion. Is an electrohydrodynamic technology in which polymer solution is fed through a needle that is connected to a high voltage power supply. The solution becomes charged as it flows through the needle, and the electrical stresses overcome the surface tension of the polymer solution. The droplets emerging from the needle converge into a conical shape, which is we name as the Taylor cone, as a result of balance between various forces, and a polymer jet is ejecting from the apex of this cone. It is this jet that leads to the production of mechanism as the solvent subsequently evaporates and instead leaves dry and uniform fibers. More recently, improvement of the portability of the electrospinning devices have allowed for point-of-need spinning of fibrous constructs with great potential in wound healing applications. The ability to directly spray an active patch into the wound patients allow the control of fiber morphology, patch thickness, material choice, easy transport and storage of nanofibrous product, and gives complete control over wound coverage and thickness. Polycaprolactone, or PCl, was used as a carrier polymer along with the 8 different ratios of bacterial cellulose to generate bacterial cellulose PCl composite nanofibers, which could be exploited, used as emergency point of need wound care using novel electrohydrodynamic gun. However, hydrophobicity is an important characteristic to consider for materials in wound healing and tissue engineering as well. It can affect biocompatibility of protein absorption and cellular interaction with material. So this is a new technique developed by our group in UCL, so called as pressurized gyration technique to produce biofiber. Pressurized gyration is a hybrid fiber forming technique which combines solution blow spinning with centrifugal spinning to form low diameter fibers with a rapid production rate that can be used to generate bandage-like fibrous mat. The setup consists of aluminum vessels with multiple small apertures on its exterior, which is connected to a high-speed motor and gas inlet. The vessel rotates at high speed and the gas solution not only allows for very high throughput of production, but also allows you to control final fiber morphology by varying the rotation speed and the magnitude of applied gas pressure. Orientation of fiber bundles to generate mats of wound dressing can be manufactured in this way. Having application in wound healing, the scaffold must be biocompatible, non-toxic, and must allow for adequate cell attachment, migration, proliferation, and differentiation. So the scaffold produced by pressurized gyration were investigated and found to be compatible with no indication of toxicity. So that's all my presentation for today. If you have any question, you can contact me at my email, and also could be reached at that phone number.
Thank you. So basically, I have done some experiments with Dr. Yayan from BRIN using the pressurized generation technique. So now what we did is we used some extraction from wooden, from natural resources, from plants in Malaysia, and then we integrate into the fibers. But that's still in prototype, still in the research lab. So we hope that it can solve quite problems with the medical. You know, like we have Tongkat Ali, we have the Kacip Fatimah, we have the Mengkudu. So all these natural resources we use and produce in fiber form. I believe Indonesia also have many natural resources that can be used, and we can translate into high technological products by using nanofibers.
Okay, Dr. Marina, thank you. I think very interesting research. Maybe we can,
I'm sorry about the hiccup of the presentation.
Okay. We are sorry too for this inconvenience because we have little trouble with our connection. Okay. Okay, we now continue for the session question and answer for the invite speaker presentation. Now we will have 5 minutes of question and answer for invite speaker. For the participant who would like to ask the question, please use the raise hand participant menu on your Zoom, or you may write down your question in chat room. We have any question, please?
I think you have question for Pak Joko.
Yeah.
Any comments?
Okay. We have 2 questions delivered to Prof. Joko. The first from Ahmad Sauki. Prof. Joko, Ahmad Sauki asks, are there the macro alga species that is not competitive with alga for using bioethanol source? And you can answer for the first question.
Okay, thank you, Pak Chairman. Actually, Pak Ahmad Sauki, we have a lot of seaweed that not edible. Among 500 more, we only utilize about the less than 20 species. And the second one, we can also use the, how to say, off-grid of seaweed that's not fulfill the industry. And the third one, we also use the byproduct from the seaweed processing. For example, if we already extract
Recording
the
in
carrageenan,
progress.
we can use the material remaining, mostly is cellulose. They can use the source of the bioethanol. That's all.
Okay, for the second question, Miss Firda, what is alga species which contain most cellulose among other algae? And if we extract cellulose from alga, can we also obtain optimum carrageen or alginate?
Okay, thank you, Pak Chairman. Bu Frida, seaweed species, class of the Rhodopiceae, especially in the Ichthyophilus and also Gracillata, contain a lot of number of cellulose. So in the production of biorefinery, just I mentioned to Pak Ahmad before, that we can extract firstly to get the kerajinan as well as the agar, and the remaining material, mostly of cellulosa, we can characterize, we can use for the other purposes. So biorefinery most important to utilize all of compound instead of seaweed material. Thank you.
Okay, thanks, Prof. Joko. Because we have limited time, maybe any answer a question for Dr. Amalina? Okay, until now we don't have a question, but I have one question for Dr. Amalina. Biofiber products from one type of raw material actually produce lower quality compared to combination of several types of raw material. Maybe you can explain what cause this to happen. Dr. Amalina, you hear me? Hello, Dr. Amalina, can you hear me? Okay, because Dr. Amalina out of this room, maybe the same.
Recording stopped.
We are trouble with connection. If we don't have any question, maybe we close this session. If you have a question, maybe you can refer directly to invite speaker. Okay, I think this session is very, very interesting with good material. We got a lot of new knowledge and other new experience. And again, I would like to thanks to our invite speaker for excellent talk today. Before we close, the committee will give a certificate to the invited speaker as a thank you for Joko. This is the certificate as invited speaker for computer. And next for Dr. Mamalia Arnil, thank you. Please once again applause to our invited speaker. Prof, thank you for your presentation. So to Dr. Amalina, thank you all. Okay, maybe we have finished the invited speaker session. Now we will start paper presentation session. In this session, we will have for presenter as below, Mr. Dera Apriani Kusuma Putri from Biophysics IPB University. The second is Sri Purwaningsih from Research Center for Applied Microbiology, National Agency for Research and Innovation, BRIN. And the next, Dr. Dani Perwitasari from Research Center for Structural Strength Technology, BRIN. And the last, Dr. Luna Nurdiati Nelgaratan from Center of Structural Strength Technology, BRIN. Before we proceed to the first presentation, I would like to check, are all the presenters already here? Okay. And I also like to gently remind you these things. We will have a question and answer too in the session after presentation. Okay, we have a limited time. For the first time presentation, for Miss Putri from Biophysics ITB. Okay, this is the short bio of Miss Della Aryani Putri. Is currently studying for this master degree at ITB Bogor, Indonesia. The current research is mainly on mechanical and thermal characteristic of mulch film made of linear low density polyethylene with addition of lignin of coconut fiber. Putri, in this presentation, we will talk about utilization extractive breeding from pulp industry waste of format UV retardant. Okay, we can see the presentation by the
Assalamualaikum warahmatullahi wabarakatuh. My name is Della Aryani Putri. As presenter, want to presentation about the paper. The title is Mechanical and Thermal Characteristic of Mulch Film Made of Linear Low Density Polyethylene (LLDPE) with addition of lignin or coconut powder. As co-author is Mercy Kurniati, Widya Fatriyasari, and Firda Aulia Shamani. This is my simple biodata. You can see it in the slide. Introduction. The base of a problem paper is Indonesia food security is declining. GFSI recorded that Indonesia food security index score in 2020 reached the level of 61.4. However, in 2021, the index fell to 59.2. This is decrease, so this is problem. GFSI assessment indicator is affordability, availability, quality, and safety. And the last, natural resource and resilience. And Indonesia have decreased value in point C and point D. We can solve it with plastic mulch. Plastic mulch is standard practice used in agriculture to control weed, increase yield, and shorten harvest time. In this picture, we can compare with the mulch soil have many advantage more than with no mulch. LLDPE advantage is strong tensile power, good at holding evaporation rate, and deficiency susceptible to photodegradation and very low biodegradation properties. LLDPE is one of best material in plastic mulch. This is a chemical structure of lignin. Lignin is the second most abundant organic substance in plant and is non-fossil organic carbon in nature. It's a natural raw material with a high content of aromatic group. We have prefers to research one mixture of 10% lignin content in composite film of Gelan gum and 2 hydroxyethyl cellulose show protection characteristic UVA 100% and UVB 90%. And 2 the varnish with 30% lignin mixture with superior to control sample after 72 hours of UV irradiation. And we can call the lignin have the best to decrease UV degradation. We have 2 lignin for the materials, black liquor and coconut powder. We choose it because the material have similar to composition of natural wool is of composition cellulose, hemicellulose, and lignin. Materials, we have LLDPE, coconut powder, and lignin extracted from black liquor of pulp industry. The method, first, lignin extraction. The extraction, step by step, you can see in the slide. Step 2, preparation coconut powder before mixing ingredients. Powdering coconut powder using mixer mill with a frequency of 30 Hz for 15 minutes. Step 3, material mixing. We have 6 treatment, lignin 159% and coconut powder 159%. Mixing in Reo mixer is processing temperature of 120 degrees Celsius, speed of rotor 80 RPM for 10 minutes. And step 5, mulching film forming by hot press. We have 2 steps, the preheating stage and the heating stage. With characteristic you can see in the slide. And step 6, crystal structure characteristic. We have 4 sample. We call it LA, LB, SKA, then and SKB. 7, mechanical properties analysis method. We use Shimizu type AGSX with 10 kN. 2 treatment for sample with a 5 kN load cell, 50 mm gauge length, and 50 mm per minute load speed. The result for analysis of the crystal structure characteristic, we have C2 figure 4 and figure 5 are X-ray diffraction pattern before and after the lignin and coconut powder is pulverized. The amorphous area greater than the of crystalline area, as shown in table 2, indicate the lignin and coconat powder contain more amorphous component. This is the table 2. It can be seen the crystallinity of lignin greater than of the coconut powder. In addition, there is change in the degree crystallinity before and after pulverization, which decrease in the crystallinity phase and increase in the atmosphere phase. Mechanical property of mulch, we have figure 6, is 9%. We have addition 9% fine powder of lignin, had a highest tensile strength value. And figure 6 show that addition 9% coconut powder result highest modulus of elasticity value. With the results 16.91 megapascal and 0.02 gigapascal. For SK9, mulch film has a low elasticity value, more rigid compared to other sample. Elongation break we can see in figure 8 with addition 5% powder of lignin, result highest elongation at break, namely 286%. Analysis thermal, we have 3 samples for lignin, LL1, L5, and LL9. And this is the result. The 3 samples have melting point that are close to LLDPE. LLDPE has a melting point 122 degrees Celsius. With the addition of lignin, the melting point changed, although not significantly. And for figure 10, we have in the exothermic process, which is the crystallization temperature TC. In figure 10, we have LL1, 5, and 9, and not much different result. And as you can see, this is a result of the exothermic, the ST curve of mulch film with addition lignin powder. And figure 11, we have LLSK1, 5, and 9. And not much different too. And this is a result for the analysis. Conclusion, we have 3. Mulch film can made by mixing LLP with powder of lignin or coconut powder. Based on crystallinity testing using X-ray, crystallinity of lignin is greater than that of coconut powder. In addition, there is change in the degree crystallinity before and after pulverization, which decrease in the crystallinity phase and increase in the amorphous phase. Mechanical property of film, we have addition coconut powder is result, you can see it 0.20249% and tensile strength is 16.91 megapascal. Analysis thermal of 6 sample, we have 6 sample LL1, 59, LLSK 1592, and this is a result of the analysis thermal. This is a reference in the paper. Okay, thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you to Ms. Dela Afriani Kusuma Putri. Okay, for the second presenter, we invite Ms. Sri Purwaningsih from Research Center for Applied Microbiology for BRIN. This is the short bio. Ms. Sri Purwaningsih. Purwaningsih is one of the senior researchers at Research Center for Applied Microbiology. She graduated from Faculty of Biology, University Gajah Mada. She's current research is mainly on rhizobacteria that promote plant growth, especially rhizobium bacteria. Okay, Ms. Sri Purwaningsih will talk about inventory and testing of rhizobium bacteria in root and soil area of Kalimantan on the growth of soybean in a greenhouse. Okay, now we saw the video presentation of Ms. Sri Purwaningsih. Okay, please.
Assalamualaikum warahmatullahi wabarakatuh. The title is My Research Inventory and Testing of Rhizobium Bacteria and Rhizosphere and Soil Area of East Kalimantan on the Growth of Soybean in the Greenhouse. In Indonesia, the need for food continues to increase, so that productivity need to be increased. The use of Rhizobacteria as PGPR is expected to be able to increase plant growth and yield. Rhizobacteria which can increase the productivity of many types of plant, one of which is Rhizobium. Rhizobium bacteria is microorganism. The life is in symbiosis with legume plant that function to nitrogen fixing, which is abundant in the air. The formation of symbiosis involves as complex interaction between the host plant and the symbiont, which result in the formation of root nodule for Rhizobium colonies as intracellular symbiont. as the effort to determine the existence of the method about diversity, characterization and effectiveness tests were carried out with the hope of obtaining potential isolate, which can be developed as biological fertilizer agent to increase soil fertility and plant productivity. The purpose this experiment aimed to obtain potential rhizobium bacteria isolate that can be developed as biological fertilizer agent. The material and method. Material, the isolate soil and rhizosphere sample were from Balikpapan and Samarinda, East Kalimantan. The isolation of rhizobium bacteria was carried out by dilution. The content the number of colonies was carried out using the plate count method. The qualitative test, the isolate obtained dua tes qualitative IAA hormone phosphate solubilizing protease and nitrogen fixing. The isolate selected were used inoculation of soybean plant as a control without inoculation and without added and fertilizer, and plant without inoculation were given urea fertilizer equivalent to 100 km per hectare. The design used was complete randomized design with each treatment 3 replication, crop harvest and 15 days. The parameter offset height, plant, dry weight of canopy, root nodule, and total plant. The maintenance humidity watering was carried per day using the nutrient solution without bond and done. The result and discussion. The experimental results show that the population of rhizobium at the rhizosphere was higher than in the soil without plant. After purification of rhizobium gave us 21 purge isolate, two isolate belonging the slow growing and 19 isolate to the fast growing group. Qualitative tests show that 11 isolate were able to produce IAA hormone, 11 isolate produce protease enzyme, 19 isolate were able to nitrogen fixing, and 11 isolate were able to phosphate solubilizing. The result of the height plant measured varied in each treatment. Observation of age 1 week, the height values was in plant inoculate with 1 isolate number 13 Ki at 2 and 3 weeks of age, and plant inoculated with isolate number 6 Ki, and 4 weeks of get in plant inoculated with isolate number 10 Ki. On the dry weight of canopy, the height valued in plant inoculated with isolate number 15 Ki, and the dry weight of root, the height valued in plant inoculated with isolate number 3 Ki, 9 Ki, and 15 Ki. The dry weight of root nodule, the foliage height in the plant inoculated with isolate number 2 Ki, and the dry weight of total plant, the height valued was in plant inoculated with isolate number 15 Ki. Of all the parameter observed, the height value was found in the plant inoculated with 15 kI isolate. Inoculation would have a significant effect if the inoculated isolate is compatible when the isolate is effective, efficient, and able to adapt to the environment and is compatible with the host plant. Conclusion. The population of rhizobium bacteria is rhizosphere rotation is greater than those without plant. The qualitative test shown that most of 21 isolate had the ability to produce IAA hormone phosphate solubilizing, produce protease enzyme, and were able to nitrogen fixation. The result, the greenhouse test showed that all inoculated isolate had a positive effect on plant growth. Of all the parameters observed, isolate number 15 kI gave the best good result. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Purwaningsi, for your presentation. Okay, we continue to the third presenter. The third presenter is Dr. Dhani Perwilasari from Research Center for Structural Strength Technology, National Agency for Research and Innovation. This is the Satyo. Mr. Dhani Perwilasari is a researcher in the BRIN and architect by education. The research expertise include traditional house, comfort and energy efficiency, CFD analysis, wind tunnel experience, and climate change adaptation. Her current research focus on Indonesian traditional house and building physics. Dr. Sari, now we'll talk about the application Indonesian building rating system for sustainable building.
Hello everyone, my name is Dhani Perwilasari and I'm from Research Center for Structural Strength Technology, BRIN. And today I will present my research. Title is the application of Indonesian Green Building Rating System for sustainable building. As we know, nowadays we facing the global warming and climate change, and one of the causes is high consumption of air conditioning to achieve thermal comfort. And this thermal comfort is not only affect the high consumption of electricity, but also increase the environment heat. So this is why building consume most of the electricity. Like surprisingly, residential building consume 60% of the electricity, and the other one is from transportation, 41%. So building envelope had a key role in reducing cooling and lighting energy consumption. So people always, especially for work in building sector and government, encourage people or owner to build a green building. And because the building envelope is comprised of opaque components such as wall and fenestration system such as window that divide the interior of the building from the exterior environment. And this building envelope can provide protection from the element of external environment such as heat, radiation, wind, rain, and noise. So if you design the envelope clearly and perfectly, it will assume can reduce the electricity consumption of the building. That is why an Indonesian government now is create a new regulation to reduce the electricity consumption called penilaian kinerja bangunan gedung hijau. and it consists of 7 different categories from the site: management, energy efficiency, water efficiency, indoor environment quality, sustainable material, waste management, and wastewater management. And this requirement is used for residential building, over 4-floor office building, commercial building, healthcare building, and other commercial building. The project must meet the prerequisite and credit requirement to achieve the certification, and there is three different certification level: Utama, Madhya, and Pratama. And then, however, in Indonesia, it's only 20 new buildings that using this certification, and this is so sad. That as we know that there's a lot of middle and high-rise building in Indonesia, but only 20 building registered as using this certification. Why? Maybe it's difficult to understand. It's why we try to analyze this and apply this system in both Jakarta and Nusantara. Nusantara is a new planned capital city in Indonesia. So we want to compare this both, and then we categorize in 3 kind of scale. First is easy, second medium, and last is hard. And then we try to use it in simple house designs, and then we prioritize in site management and energy efficiency, since these both requisite is almost 50% of all the analysis. And then for the site management, the majority of credit categorized as medium, and then one is categorized as hard, is site management. And then Indonesian housing is mostly developed by government and private companies, especially in Jakarta and Penajam Pasir Utara. So to achieve this category, the owner, the government, and developer must collaborate. Among the credits marked as easy are building orientation, site management, open space, pedestrian area, parking, and lighting system. Second is energy efficiency, is categorized as hard and medium. Medium is input envelope, cross ventilation, lighting, transport, and electrical system. And the hard is our air circulation energy efficiency, because both of these calculation need a software to and a specific knowledge to calculate and understand the result. And then the water efficiency is one is calculated easy, and then the other medium, and the other one is hard. This is because to improve the efficiency of water use, a measuring device is needed. So a detailed plan and calculation are needed for the installation. In addition, the technology should be adapted from the site condition. So if we do not know the condition of the site, it's difficult to apply this one. Aside from water management and efficient use, vegetation should be received the attention, as we know that vegetation also one of factor that produce the water. So this category could be include the guide to design and planning the water efficient landscape. And then the other is in the air quality. One is calculated easy and the other one is hard. Easy because we just provide the space for smoking area, and it's hard because the building have a risk to accumulation CO and CO2 concentration, such as kitchen and indoor parking space. And the technology of the exhaust fan need to be complete with the sensor system. And then the other is sustainable material. It's also calculated as hard, since this prerequisite mandatory to use eco-labeling material, and the eco-labeling should be available in the shop and other part, but it usually difficult to find, and because there's insufficient information about the eco-labeling, so it's difficult to persuade the sustainable material. And then for the waste management, is the majority as hard because it's necessary to collaborate between the owner, designer, urban planner, and government in order to organize the waste. And the wastewater management also calculate it's hard because disposed place not yet incorporated into current construction practice. And then we try to calculate for to the simple house, and this house is designed with passive house to reduce the electricity. So from the envelope design, it's get the full point because it's not using the air conditioner system. It's using natural air conditioning, natural air circulation. And then for the lighting system, it's not maximized because in the bathroom, there's only small amount light. And then for the transportation inside the building, it's calculated for full mark because it's only one level of building. And then for the energy analysis, we do a simple simulation, and it shows that the average each month, the energy consumption of model house is lower to 0.5%. So in this case, the design is earned for 0.5 points. For the electrical system, we don't need a point for this one because
Recording in progress.
the design, and as a result, 80% of the point were achieved with this design. And then for the conclusion, the application of rating system is for this house is heavily on discuss more all the stakeholder, including architect, engineer, and government and communities. And Indonesian expert in the building sector should take part in the contribute in this project. For the future research, it will continue to develop, focusing on the external design, not only the building, but also surrounded area. Thank you for listening.
Okay, thank you to Ms. Purwaningsi for your presentation. Now we have the last presenter for the second session. The presenter is Dr. Luna Nurdiati Jaratan from Research Center for Structural Strength Technology, National Agency for Research and Innovation BRIN. This is the biodata from Ms. Luna. Ms. Luna was born and raised in Makassar. His bachelor degree at the Department of Civil and Environmental Engineering of University Gadjah Mada. She got her PhD degree at University Nevada, Reno, USA. His research interests are vision-based structural health monitoring, drone deployment, and technology of hazard mitigation, computer vision and digital signal processing, structural and earthquake engineering, and material modeling simulation. In this opportunity, Dr. Luna will talk about comparison of green concrete performance using a digital image correlation algorithm based on video camera and smartphone data. Dr. Luna will deliver the result of her team's research to a live presentation. Dr. Luna, you have 8 minutes to present your paper. Okay, time is yours, Dr. Luna, to present your presentation.
Okay, thank you so much, Mr. Chairman, Dr. Darmawan. I hope you can hear my voice clearly.
Okay.
Okay. Yes, thank you so much actually for the committee for allowing us to present our work through live streaming. My name is Luna Nurdianti Ngaliarakan. I'm currently working as a researcher at the Research Center for Structural Strength Technology. Today, I'm going to present our work about the comparison of green concrete performance using digital image correlation or DIC algorithm based on video camera and smartphone data. I would like to acknowledge my colleague here at my research group, Mr. Agung Sumarno, Mr. Agus Mudoprasetyo, Mrs. Dani Perwitasari, and Ms. Maidina. Also our colleague at University of Nevada, Reno, Dr. Muhammad Mustafa, who actually put the foundation of all the DIC and computer vision works that we're going to present today. So for the brief background, as a civil engineer, computer vision actually interests us a lot, especially for us who work in the field of structural health monitoring. We even need to took courses from the computer science department in order to understand more about this algorithm. DIC itself is an optical non-contact method. So optical, so it means that we're using camera in order to measure mechanical or any characteristic of a specimen on the surface, either is a displacement, strand mapping, crack propagation, etc. For the common applications, most of the technique actually, they've been used in NASA and Boeing. Here for the material testing wise, we just would like to introduce it's almost a large-scale test actually. This is a specimen of a concrete tested at University of California, Berkeley. It was actually a 3.1 bending test where we monitored the specimen using the DIC technique in order to get the strain as well as the crack mapping. The key for the DIC technique first is the stochastic pattern, which is we need to actually mark the surface of the specimen. And the second one, of course, is the algorithm. The algorithm is actually pretty simple, but here the one that we would like to emphasize in order to get the exact match between the image consequences was the normalized cross correlation algorithm. I believe most of you, especially who work in statistics, already understand about this algorithm. So basically, if we get the NCC of 1, it means that we are going to get the exact match between our data consequences. It means that we can get data actually. But if the NCC results in 0, it means there will be no data. So if we record in the continuous time domain, there will be some missing point in our data. So this is why it's really important to actually get this algorithm to work. In the previous work, we already tested the DIC algorithm on the 4-story steel frame. It was a seismic test. We conducted several seismic tests, seismic tests or a free vibration test on this specimen. At the beginning, we use a really expensive camera. This one is a high-speed camera. We use 2 cameras here. And then in order to validate our data, we compare our DIC results with the accelerometer of course, in the acceleration time domain. And we compare the data with the string potentiometer if you want to get a validation in the displacement time domain. This one is just an example of the result from one earthquake. This one was from ground motion number 2. I think this one is from Rinaldi earthquake. The maximum displacement is about 66 millimeter. This one is just the ground motion characteristic. The maximum acceleration is 0.68 g, so it was really pretty huge. The total duration of the record itself was 20 seconds, and then we just recorded for the first 6.5 seconds. And these 3 images were the results from the DIC. If we compare the measurement between DIC and string pot, we could get like 10%. This one, again, this one, I just want to emphasize, this one was our first very initial test. After this, we could get the accuracy up to 99.97%. It means that it is associated with the error with 0.03%. So the accuracy is actually really important in the health monitoring. This is why the terms that I'm going to talk about, even after the rest of this presentation, is going to talk about the accuracy. Yes. And then because we want to measure using cell phone, we conducted several measurements using a cell phone. I monitored a specimen using cell phone as well, but this one we just want to introduce that in the past we worked with a drone. Drone also has a camera, and here we compare the data between the drone and the smartphone as a reference sensor. And as you can see here, after data processing, we could get a pretty comparable results with the error associated with the error as 2.48% that is associated with the displacement accuracy of 97.52%. So for the initial test that we conducted, the result was pretty satisfying for us. Now, if you talk about the green concrete, Here we tested 3 specimens. They are actually porous concrete. If you would like to ask about the mixed design, of course, I'm going to direct to my colleague because the concrete mixed design or concrete area is not my area of expertise. But here we just conducted DIC monitoring on these 3 specimens. These 3 specimens were tested under several loading, but the one that we're going to present here was the one from the compressive test. And of course, using the DIC algorithm is really easy. You can just like apply the pattern and then use single camera and then do monitoring and get the data. So it's really pretty simple. And then, of course, the objective, we just want to offer the practical application because the methods, the instrumentation, as well as the method, they're very, very simple. It's really fast to be deployed in the field. And then, of course, we just want to compare for the first time the mechanical properties using DIC focusing on 2D displacement and strain between the commercial DSLR camera and the smartphone camera. And here is just the specification of the material. First, the dimension of the cylinder, concrete cylinder, was 20.5 centimeter in height and 10 centimeter in diameter. We applied the stochastic pattern. We monitor using 2 systems, and each system actually only consists with 1 camera. So the first system as a reference, we use the DSLR camera, and the second one is a smartphone. Of course, we cannot mention the brand here, so I just give you the specifications. And then the data that we present here are the data from the concrete test day 14, and these are the 3 FC prime for these 3 specimens. So we got like almost 14.22.23 megapascal. And again, this is a porous concrete, so we cannot get like you cannot. I mean, it's really early if you want to achieve like about 30 megapascal or something for the concrete idealized for structural application. So this one is the results in the displacement time domain. First is displacement in the x direction or the x direction. So as you can see here, when for the first specimen, the loading, the displacement was not that much. So if you see the difference between these 2 systems, DSLR camera, commercial camera, I'm just going to mention as commercial camera and the smartphone, they're pretty much comparable. But once the displacement increases, then we start like seeing a trend. So in health monitoring, we say this one is a systematic error, because once the value increases, if we say one of the sensor actually gives us a correct result, then it means that the systematic error means that the value starts like going higher or lower than the reference sensor, than the reference value. The similar trend also is also observed. This one is in the vertical direction. So if we talk about compressive test, it means that this one is the value displacement at the loading direction. But here we observe like smaller error. But again, once we also still observe like a systematic error between this data, these 3 specimens, except for specimen number 6, we do not observe that much systematic error. But for the specimen number 1 and number 7, we actually can see like how actually the error, or not the error, but the difference between these 2 data start increasing once the displacement value starts increasing as well. And for the strain map, this one is the strain in the x direction. If you work with the material value, so it's really nice actually to use this technology, you can use strain mapping. So this one is the displacement in the, strain in the x direction. And as you can see here, the similar trend is observed is once the strain percentage start increasing, then you can see the error, the difference between these 2 data here. And then here, if you see, this one is just an explanation between these 2 images. So the first image on the left was the image of the cylinder before the testing, so at initial condition, and the one at the last one was at the end of the test. So this one is at the failure, so you can see the shear failure, even the falling of the concrete. And this one is the strain in the vertical direction or in the loading direction, and of course we observe a similar trend here once the strain values or percentage starts increasing. So at the end, what we can say is that first, like efficient and fast as a efficient and fast technique, actually I see it's actually a pretty promising method to be applied either in the lab or in the field. But then since we get an error, and then here we compute the maximum error that we get from this test, this 3 specimen was almost more than 12%. So this one at the initial test, this value actually is really huge. And in order to remove the systematic error, we did not put it here. We would like to introduce the second camera. So instead of using a single camera to monitor the specimen, we would like to use two cameras so we can do the 3D measurements, and also we can remove the systematic error so we can get a more accurate data for all of our measurements. And then we can continue to get more mechanical properties of the green materials. Thank you so much. These are my email. If you would like to, if you are interested, you can shoot me emails, or if you would like to collaborate and working with the IC, just shoot me an email. Thank you so much.
Dr. Saptadi, I think you're still muting your voice.
Okay. Thank you, Dr. Luna, for your nice presentation. Now we will have a question and answer session. Anyone to ask question, please can you raise your hand in the chat room or direct a question. Okay, if have a question, please. Have question, Miss Arlina.
Oh, okay, sorry. Thank you for the opportunity for me to give the question. Firstly, I would like to appreciate all the presenter for their very interesting presentation. I have two questions for two different presenters. The first one is for Ms. Della. I want to know what is the purpose of adding hydrochloric acid in lignin extraction from black liquor. Is it just to reach the pH of 2, or there is another function? And the second question for Ms. Della is, what is the correlation between crystallization of black liquor and coconut fiber powder to the plastic mulch properties? And my third question is for Mrs. Sri. I look at your research result that there is a difference in the population of rhizobium bacteria obtained from these different plant species. What can cause these differences? Thank you.
Okay, refer the question to the first and second presenter. Okay, Dr. Della or Ms. Purwaningsih to answer Arina question. I'm sorry, Dr. Della or Ms. Purwaningsih, you have still in this room?
Okay. Can you hear my voice?
Yeah, it's very clear.
Yes.
Okay. For the question 1 is, what purpose is adding hydrolytic acid? Hydrolytic acid, right?
Yes.
Okay. Adding hydrolytic acid.
Okay, I'm sorry, Dr. Della. No? Is still here, Dr. Dela?
Maybe Dr. Dela lost her connection. We could continue to other question, maybe, Dr. Saptadi.
Yeah, next question you refer to Miss Riperwaningsih. Miss Erwina. Okay, Riperwaningsih, I think is out of this session. Okay, because we have limit time, this is Friday. Once again, thank you for presenter for the second and first session. After finish this session, the event will be temporarily suspended to lunch break and Friday prayer. We will start again next session before at 1:30 in afternoon. Before we close, maybe if you can get the photo session, please, Mr. Dia, you for get the photo session. Please open your camera for this session.
All right, everyone, please turn on your camera. We will have photo session because we still have Professor Joko here. Unfortunately, Dr. Amalina is not with us. All right, we have 2 pages for the first page. One for the second one. Smile. 1, 2, 3. Okay, thank you, everyone.
Okay, thank you, everyone. Maybe we close the session. Thank you again for all presenters. We will meet next after Friday praying lunch this afternoon. Thank you for all. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Prof. Joko. Thank you very much for your time.
stopped.
Good afternoon, ladies and gentlemen. Thank you for staying here with us this session. And now we continue to the session 2 of the presentation and parallelization. I think for the next session, we already have almost our speakers, our presenter to get standby in the Q&A session. So please, co-chair, Ms. Elena, you can start.
Thank you, Ms. Ayu, for the opportunity. Good afternoon, ladies and gentlemen. Welcome back to the third part of ICONLIG 2022 Parallel Session 6 that focuses on the biopolymer topic. I hope all of you had a great lunchtime and ready to continue our discussion. First, please let me introduce myself. I'm Erlina Nurul Aini from the Research Center for Biomass and Bioproduct. It's a real pleasure for me to take place as the moderator for the third and fourth part of this parallel session. Like in the previous parallel session, the rules for the third and fourth session are the same. Firstly, I will briefly introduce each presenter by reading their short bio, and then the IT team will help to play the presentation video of each respective presenter. The Q&A session will be held at the end of the session. The time for the Q&A is around 10 minutes. For the participants who would like to ask a question, please use the raise hand function, or you may write down your question on the chat room during presentation. And we will also have a photo session in the end of our session, so please stay tuned until the end. Okay, let's proceed to start our third session. In this third session, we will have 5 great presenters, which all of them are from BRIN. The first one is Mr. Fahriansyah, and then Dr. Muhammad Adli Rahandi Lubis, Mr. Raden Esa Pangersa Gusti, Professor Adi Santoso, and the last one is Mr. Raden Permana Budi Laksana. Before we go to the first presentation, are all presenters already in this room? Miss Dia?
Yes.
Mr. Esa Pangersa is still not join us, but I will contact him immediately. So we can continue, please.
Oh, okay. I will continue to the first presenter. The first presenter is Mr. Fahriansyah. I will give a brief introduction of him. Mr. Fahriansyah is a researcher from BRIN, and he's graduated from Trisakti University. His current research are mainly on machine design. To the IT team, please play Mr. Fahriansyah presentation video. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, in this insightful section of the second ICONLIG 2022, allow me to thank for the opportunity that has given to us to present the article with the title Solar Drying, Performance and Post-Drying Quality of Oil Palm Lumber from Two-Stand Egg and Sampling Position Within the Trunk. Let me introduce the speaker and the author team. The speaker today, I am Fahriansyah, and the author team are Kanita Yuniarti, Evita Basri, and Jamal Balfas. We are from Research Center for Biomass and Bioproduct BRIN Indonesia. In the context of oil palm lumber, no previous studies have been done in evaluating influence of use internal wood factor on either its drying process or final quality. The oil palm lumber itself is generally considered as was generated from the replanting activity of oil palm trees. In many plantation area, the replanting activity is carried out when the oil palm trees reach 25 years old. However, there are some minor cases where the oil palm trees are replanted at 32 years old. This study was then performed. The main aim of study is to explore the possibility for applying solar drying for oil palm lumber and investigate the effect of two internal factors, the stand egg and the sampling position within the tree on both the drying performance and post-drying quality of oil palm lumber. The main material used we are the lumber of 25 and 30 years old oil palm tree and collected for a small farming area in Lebak, Banten. Both stand egg are the actual common filling eggs of oil palm trees in the field before the old tree and replaced with the new plant. The sampling each tree was divided along its length into 6 logs of length 1,500 millimeter. Part 1 and 2 refer the log taken from the bottom part of the tree. Code 3 and 4 to the log from the middle part, and code 5 and 6 the log from the top of the tree. The end of the remaining board were sealed with glue and aluminum foil before being drying in the solar kiln. Drying experiment, all sealed boards were wiped and measured before they were stacked inside the solar dryer. A 20 millimeter sticker was placed between line. The drying process was run in August 2019. The temperature and humidity range inside the dryer were 30 to 40 degrees Celsius and 70 to 85% from morning to afternoon. Data collection and analysis. The shrinkage value in the width and thickness were each calculated as follows. Shrinkage as percent equal initial dimension minus final dimension divided by final dimension times 100%. Drying performance, the green moisture content of oil palm wood used in the study reached approximately 500%. The MC increased from the outer part to the inner or center part of the trunk. It also increased slightly from the bottom to the top part of the trunk. The drying rate ranged from minus 0.1101 to minus 0.03 to 0% per hour for the 25 years old wood, and minus 0.4834 to minus 0.076% per hour for the 32 years old wood. The 30 years old would need 144 to 672 hours to dry, where the 25-year-old would need 168 to 264 hours. Further, the statistical analysis confirmed the significant effect of the stand egg and the vertical sampling position on the drying rate and the fly rate of oil palm wood in the table 2 and 3. This result assumed to be affected by anatomical structure of oil palm wood, in which the vascular bundle portion and the dimension of the fiber diameter, length, and wall thickness increase slightly from the bottom to the top part of the trunk. The shrinkage generally decrease as the age of the oil palm wood increase, the table 4, and intended to increase along the tree length and the transversal surface of the log for the 25-year-old wood. The shrinkage range were 1.90 to 19.33% for the width, and the 1.57 minus 2 to 16.51% for the thickness. This unexpected result could be because the initial MC found in most of the 25 years old sample were lower than that in the 32 years old sample. The shrinkage further statistical analysis confirmed the significant influence of the stand edge of the vertical and horizontal sampling position on the shrinkage. Table 5 and 6, the top part sample also shrank more than those from the other part of the trunk, shrinking approximately 15.58% in width and 17.98% in thickness. Drying defect in the table 7 show that the oil palm wood from the both stand egg tended to develop more surface check than end check. The tendency to develop both check decreased as the stand egg increased, and the inner zone sample were more prone to the development of external check than the outer sample. Drying defect, the longest end check was observed in 30 years old wood sample taken from the inner zone of the trunk at the starting height of 3,000 millimeter. The same results were also observed in the surface check. Post-drying quality, the inner zone oil palm wood tended to develop more bowing and cupping than the other zone sample in the table 8, and more spring and twist were observed in sample from the outer zone oil palm wood than in the inner zone sample. Table 8 also showed that the tendency developing collapse increased as the age of the oil palm increased. The percentage of 30 years old wood affected by collapse was approximately 40.77% higher than that of 25 years old wood. Drying defect, the depth of any distortion defect tended to increase as the age of oil palm wood increase in figure. Sample taken from the inner zone of the both egg group were more prone to collapse than those taken from the other zone. In a review of the development of collapse during the drying eucalyptus wood, several pre-treatment were recommended, including preheating, pre-steaming, microwave pre-treatment, pre-freezing, and boiling. This recommendation could also be adapted for oil palm wood. And the conclusion, the stand edge and vertical sampling position along the trunk length were found to have significant effect on the drying rate, drying period, and post-drying shrinkage of oil palm wood. The horizontal sampling position along the transversal surface of the trunk was also found to have significant effect the post-drying shrinkage. On average, the 25 years old oil palm wood had the fastest drying rate, approximately -0.06% per hour, and the shortest drying period, approximately 232 hours. As the stand edge of oil palm wood increased, the tendency to develop external check decreased, but the depth of all the distortion defect and the tendency to collapse increased. The longest and check and the most surface check magnitude were both observed in 30 years old wood taken from the inner zone of the middle part logs. Bowing was the most dominant distortion defect for 25-year-old wood, developing in 65.28% of sample, whereas twisting was the most dominant defect for 30 years old wood, developing in 75.81% of sample. The percentage of 32 years oil palm sample affected by collapse was approximately 40.77% higher than that of the 25-year all sample. The inner zone sample shrank more than other zone sample, and they were more prone to develop external check, bowing, cupping, and collapse. In contrast, the other zone sample tended to develop more spring and twist than the inner zone sample. And all that's the presentation. Thank you for attention.
Okay, thank you for Mr. Fahriansyah for the very informative presentation, and also thank you for the IT team for playing Mr. Fahriansyah video. Okay, we move on to the next presenter. For the second presenter, we have Dr. Adli Rahandi Lubis. Dr. Adli Lubis got both his master and doctoral degree from Kyungpook National University, Korea. He is a researcher in the Research Center for Biomass and Bioproducts. Dr. Lubis' research interests include wood adhesives, wood adhesion, and polymer composites. Okay, to the IT team, please help me to play Dr. Adli video. Hello. Okay.
Recording in progress.
Hello everyone, my name is Muhammad Adli Rahandi Lubis. So today I would like to share our research on properties of bio-based non-isocyanate polyurethane resins derived from viscose tannin of acacia magnum bark, dimethyl carbonate, and hexamethylene diamine. So this work was conducted from the collaboration between the IVD University, University of Padjadjaran, and also University of Sumatera Utara. In this study, we want to develop an alternative for the conventional and commercial polyurethane resin. Polyurethane has a high mechanical strength, has the ability to form rigid, semi-rigid, or flexible form, and it has been used in many industrial sectors. The isocyanate, the polyurethane derived from the isocyanate and polyol, which is unrenewable raw materials, and also it has high toxicity and non-environmentally friendly. So in here, we want to prepare an alternative for the isocyanate and also the polyol. For the polyol, many renewable resources has been developed, mostly from lignocellulosic biomass, lignin, and tannin. In this study, we use the tannin extract from acacia magnum bark as a starting materials for the biopolyol. And to form a non-isocyanate polyurethane resin, we react the tannin with the dimethyl carbonates and then cross-link it with hexamethylene diamine. So the objectives of this study is to synthesize and characterize bio-based isocyanate polyurethane resins, we call it bio-NIPU, derived from the tannin condensed extract of acacia magnum bark, dimethyl carbonate, and hexamethylene diamine as a substitute for the conventional polyurethane resins. So this is the material we use in the study, the acacia bark with 40 to 60 mass, we obtained from Tanjung and Industri Pulp and Paper Industry, Palembang, Indonesia. And for the carbonation, we use dimethyl carbonate. It was 90% concentration from Merck. And then for the cross-linker, we use hexamethylene diamine with 98% concentration from Sigma Aldrich. First, for the extraction of tannin, the acacia magnum bark was mixed with water. So in here, we use water as solvent with a ratio 1 to 10. And then the mixture was heat it to 60 degrees Celsius and stir for 6 hours. After the extraction, after the first extraction, it was then filtrated to separate the bark and the brown filtrate, which is rich of the tannin. And then we do the extraction again up to 6 times until the final filtrate become colorless, which is no tannins in the solvent. So after that, the extract or the filtrate was evaporated at this condition until we get the viscous tannin extract. And then we do the characterization for each solids contained, viscosity, functional groups, and thermomechanical properties. Then, for the preparation of the tannin bio-non-isocyanate polyurethane resins, we do the carbonation reaction. In here, we react the tannin with the dimethyl carbonate with a ratio 1:1 and 1:2 at 50 degrees Celsius for 15 minutes. And then we can get the carbonated tannin. After that, the carbonated tannin will react with the hexamethyldiamine to form a cross-linked polymers, which is a tannin bio-non-isocyanate polyurethane resins at 50 degrees Celsius for 30 minutes. And then we characterize the viscosity, the functional groups, and thermomechanical properties of the tannin bio-non-isocyanate polyurethane resins. For the results, from the FTR spectroscopy, we can get the spectra of extract tannin, the carbonated tannin, and the tannin bio-polyurethane resin. So in here, a typical tannin spectra, which with hydroxyl groups at 3,325. And after we react with the dimethyl carbonates, we can get the carbonated tannin, which are typical carbonyl groups at 1,752. Then, after the cross-linking with the hexamethyldiamine, we can get the tannin bio-polyurethane in solid and liquid, which has urethane group at 1,665 and 1,694, depends on the state. So from the FTR spectroscopy analysis, we can create a scheme reaction. First, the carbonation between tannin and dimethyl carbonate will produce a carbonated tannin, and then the polymerization or the cross-linking, we can between the carbonated tannin and hexamethyldiamine will produce tannin bio-non-isocyanate polyurethane resin with a typical urethane linkages in here. So for the viscosity, coherence rank, and the Tar keys, this result was obtained from a rotational diameter analysis. So in here, we can see that the tannin bio-polyurethane has the highest viscosity, cohesion strength, and also Tar keys. And then followed by the carbonated tannin from tannin DMC, then the carbonate, and finally tannin extract. The similar trend was obtained for the viscosity, cohesion strength, and also Tar key. For thermomechanical properties, in here we can get quite similar trend to the viscosity analysis, which tannin bio-polyurethane resin has the highest storage modulus, loss modulus, and the lowest time delta. This shows that the polymerization of tannin with the dimethyl carbonate and hexamethyldiamine can create greater modulus strength with highest elasticity, which is can be seen in low time delta in here, low damping properties. So the resulting tannin bio-polyurethane resin, it has quite good elasticity compared to the carbonated tannin and the extract tannin itself. For the viscoelastic properties, this was obtained from the dynamic mechanical analysis. In here, we want to justify whether the result of the viscosity is similar with the viscoelastic, and then we can see that the storage viscosity and loss viscosity of the tannin bio-polyurethane resin has was higher compared to the community tannin and the extract tannin itself. So this result is similar to the result of the rotational rheometer. So for the conclusion, we can say that the tannin bio-based non-isocyanate polyurethane resin has been successfully synthesized using acacia-manganium tannin, as confirmed by the formation of urethane bond by FTIR spectroscopy. For the thermomechanical and viscoelastic properties of the resin, it can be determined by looking at the parameters such as viscosity, cohesion strength, torches, starch modulus, loss modulus, and damping factor or tan delta. And tannin bio-non-isocyanate polyurethane resins has the highest starch modulus, loss modulus, and tan delta compared to the viscose extract tannin and the carbonated tannin. Thank you very much for your attention. This study was supported by the Riset and Inovasi Indonesia Maju, PRN, project number 6527HK 2022, with title Teknologi Pengembangan Serta Rami Tahan Api Terintegrasi Resin Polyuretan sebagai bahan baku tekstil fungsional. Thank you.
Thank you, Dr. Adli, for the very interesting presentation, and also thank you to the IT team. Okay, let's move on to the third presenter. We have Mr. Raden Esa Pangersa Gusti. Mr. Esa is a researcher from the Research Center of Biomass and Bioproduct. He graduated from University of Seoul, Korea, and his current research are focusing on non-timber forest product. Okay, to the IT team, please play Mr. Esa presentation video. Thank you.
Hello, everyone. Today I would like to present our paper entitled Performance of Fortified Noodle Made from Konjac or Porang and Palm Sagu Flour. The author are me, Raden Esa Pangersa Gusti, and Gunawan Pasaribu. We are from Research and Innovation National Agency for BRIN, Indonesia. This presentation divided into 4 parts. First, introduction. Second, methodology. Third, result and discussion. And last one, conclusion. So let's start. Talk about food. Food is human basic needs. Along with the increasing rate of population growth, the need for food also increases both in quality and quantity. The staple food consumed by most Indonesians is rice. This increasing independence on rice encouraged the research for the other alternative food that grow in Indonesia. And now we brought to you sagu. Sagu is non-rice carbohydrate source that are widely available in Indonesia. Almost 98% content of sagu is carbohydrate. Unfortunately, the consumption of sagu is still very low. In other hands, Indonesia also faced the problem with micronutrient deficiencies. Lack of absorption of micronutrient can lead to disturbances in health, growth, and other functions in the body. Therefore, if sagu is consumed as a staple food, modifications need to be made to improve its nutritional value through fortification process. However, not all components can be fortified. And now we brought to you porang and sagu palm, which are non-timber forest products that have potential to be developed as natural fortificants due to their various advantages in terms of cultivation and processing. Porang is widely consumed in Japan as a source of fiber called shirataki. It has rich micronutrients of glucomannan, calcium, and iron. In Indonesia, porang is abundant quantity. So combination of sagu and porang we can create alternative functional food with high nutritional value or superfood. For the methods, we focus on main material is porang and sagu. The other material is like wheat, sugar, and the other parts. For processing material, we did in-house in our laboratory in Bogor. And for the laboratory test was carried out at the Center for the Agro Industry, Bogor. The research method used experimental method, namely conducting experiments for fortification of porang and palm sagu on wet noodles. The method of making wet noodles refers to bogasari, and we provide to you 6 type formulations as can be seen in the table below. For formula of F1, it is the control. It means we don't involve any sugar, any sagu and porang inside of it. Where the F2 to F6, we did the treatment by combinations, different concentrations of sagu and porang. And for the analysis, we did approximate analysis, metal contaminations, mineral content, microbial contamination, and organoleptic tests. So the result is, first, we see the noodles characteristic of our research product. As shown on the screen, we can see that noodles with porang mixture show the presence of porang flour grains or granules on the surface of the noodles we serve. Different with the Formula 1, we see that Formula 1 is control, so without porang and without sagu. Then the difference is on the performance. So noodle with porang show the granules or grains on the surface. For proximate analysis, we found that water content based on the Indonesian standard, all of the formula do not meet the requirements. Indonesian standard required for water content is 20 to 35%. Same as the water content, ash content also do not meet the requirements because the value is higher than maximum requirements. However, the other parts is meet the requirement of Indonesian standard, and we found that total fat of our product is higher than noodles from sagu and sorghum. Protein also, we found that the value of protein higher than noodles from sagu and sorghum from the literature study that we read, we get. And for the mineral content, metal contamination, and microbial analysis shown on the screen, we found that all of formula meet the requirements of Indonesian standard. It's good point for us because our product, first product, have a good characteristic. In organoleptic test, we found that the assessment overall on a score scale of 3 to 5, which means that the most of respondent or panelists like the wet noodles product served. And from the average data, we found that formulation of F2 or Formula 2 is the most preferred formula based on the organoleptic test. Based on statistical analysis, we found that formulation had a significant effect on overall product value. And then we found also here we can state that Formula 2 is the best formula because the summary of done test, we found that Formula 2 shows letter A without any other letters. It really close to the F1 while the F1 is control. So from the preference of respondent based on age, gender, and level education, we did a B-plot analysis from MCA, and we found that female prefer Formula One only, while the male prefer Formula One and Formula Two, and so on. So we can find out the perception of the value based on their characteristic here. And the last one, we did the cost analysis for the noodles, and we found that for 0.5 kilograms of porang sagu noodles, it costs 16,791 rupiah. This price is still above the market price. However, we have added value by benefits of nutrition by fortification process, so it's still quite comparable based on the study. And the last part, we can conclude that based on the study, fortification process of porang and sagu into noodles product was successfully conducted. Fortification process proven increase the nutrient content, such as we can see here, and also the calcium content was double because of addition of sagu and porang. Formula of F2 with composition of wheat, sagu, flour, and porang 80, 10, and 10 was the most preferred according to organoleptic test. And the porang sagu noodle production cost is 33,581 rupiah per kilograms. That's all presentation from us today. Thank you for your kind attention.
Thank you, Mr. Esa, for the insightful presentation, and thank you for the IT team. And then we move to the fourth presenter, which is Professor Adi Santoso. Professor Adi Santoso is a research professor in the Research Center for Biomass and Bioproducts. He got his doctoral degree at Institut Pertanian Bogor. Professor Adi current research are mainly related to the biopolymer. For the IT team, please help me to play Professor Adi video.
This paper written together with Jamaluddin Malik, the title of Formulation and Characterization of Bioresin made from oil palm extract for wood adhesive. Introduction. The production of wood from natural forests is currently declining. To address the shortage of wood raw materials, effort must be made to diversify the sources of raw material for the timber industry through the development and use of seasonal or fast-growing wood species, as well as the development of technology for utilizing these raw material sources. Indonesia is one of the largest producers of palm oil in the world, which produces about 31 million tons of palm oil in 2015 from the area of 11 million hectare oil palm plantation. This quantity of production results in oil palm trunks that are no longer productive after approximately 25 years, which are typically left on the plantation site or abandoned once planting activity commences. On the other hand, the technology that needs to be continuously developed as that of adhesive, with the goal of discovering alternatives to synthetic adhesive that are made from petroleum. Attempts to obtain adhesive from natural material continue. The use of tannin can reduce the consumption of phenolic compound derived from petroleum as well as decrease relying on imported adhesive. Tannin that can be utilized in adhesive formulation for laminated wood can be extracted from the abundance of wet oil palm bark. This involves the addition of fortifier and cross-linked agent, such as phenol and desorptional, thereby reducing the use of synthetic adhesive and lowering production costs while maintaining quality. This paper discusses on the adhesive formulation from oil palm bark waste extract of various compositions that can be applied for laminated wood. Material and the method. Material consists of palm oil bark extract, resorcinol, formalin, formaldehyde resin, distilled water, extender, and ethyl acetone, etc. In the table 1, we can see the proportion of the resin composition consists of formulation, extract, resorcinol, formaldehyde, and resin of phenol formaldehyde. And the method consists of bioadhesive manufacturing, bioadhesive characterization, and bioadhesive application for glue, laminated second wood. The bioadhesive manufacturing consists of we weigh resorcinol and extender, and then put into a beaker and dissolve with extract, and add the hydroxide until we add 10. And then the mixture of continuous state until homogeneous, marked by a change in the color of the solution to blackish red, texture, and has a fragrant aroma, and then done at room temperature. For bioadhesive characterization, consists of appearance test, solid content, specific gravity, viscosity, Galvanic time, and pyrolysis DCMS analysis. And for bioadhesive application for laminated second wood, is used to make laminated wood. And then the adhesive polishing method was used to glue to surface with a glue spirit of 170 gram per square with double spring. Furthermore, the adhesive coated laminates are arranged and compressed for 8 hours in a cold press machine with a special pressure of 1.47 MPa. The laminated wood is conditioned for 7 days before being tested for physical and mechanical properties at room temperature. And the physical and mechanical properties of laminated wood were evaluated, including moisture content, density, delamination, and formaldehyde emission. This is the result and discussion. Consists of characteristic of oil palm bark extract. In the table 2, we can see characteristics of oil palm bark extract. Consists of appearance, acidity, anti-molecular weight distribution. And figure 1, we can see DCMS pyrolysis chromatograph of palm bark oil extract. And in the table 1 and in the table 3, we can see photometric of chromatographic absorption band of panel compound of palm bark extract. We can see that the total of phenolic about 3/10 in percent. And then this is characteristic of bioadhesive made from oil palm bark extract. We can see that in table 4. This is bioadhesive characteristics of the bioadhesive, consists of acidity and the distribution of molecular weight. And then in the figure 2, you can see bioadhesive chromatograph without the addition of phenol formalization. And in the table 5, we can see photometric chromatic absorption band of bioadhesive phenol compound without the addition of PF resin. We can see the total phenolic after a bioadhesive phenol compound about 14.96%. In the table 6, you can see photometric chromatic absorption band of bioadhesive phenol compound with the addition PF resin. You can see the total of phenolic 10.89. And last, in the bioadhesive application for laminated timber, in the table 7, we can see about quality of single laminated wood with various variants of bioadhesive. A conclusion: the best composition of the addition of phenol formaldehyde bioadhesive was found in the extract formulation, resorcinol and formaldehyde with 7.5%, with a specification of pH 11, showing content of 10, specularity of 1, viscosity of 0.0 voice, chemical compound content of 10 component, and total phenolic content of 10.9%. In its application to single wood, the formulation produced a density of 0.3 gram per centimeter cubic, moisture content of 10.9%, and with the GIS standard. With 0% denomination with the GIS standard 2, and the resulting emission concentration of 0.1 ppm with the GIS standard with the F4 classification with a very safe description. Judging from the addition strength of the laminated variant, Shangon with 7.5% PF had the highest adhesive strength, namely 36.9 kg per centimeter square in the dye test and 16.4 kg per centimeter square in the wet test, and meet the SNE standard. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for Professor Adi for the very interesting presentation, and thank you for the IT team for playing Professor Adi video. Next, the last presenter in this third session, we have Mr. Raden Permana Budi Laksana. Mr. Raden is a laboratory research technician at Research Center for Biomass and Bioproduct. He graduated from Universitas Indonesia. He has H index of 6 and has published around 18 scientific articles. His current research is related to the low emission formaldehyde adhesive. To the IT team, please play Mr. Raden presentation video. Thank you.
Good afternoon, all the participants. Allow me to present our research title, Influence of Different Organic Acids Hardener on Performance of Ultra-Low Molar Ratio Urea Formaldehyde Resins Adhesive. The outline of this presentation are introduction, objectives, materials and method, results and discussion, and conclusion. Urea formaldehyde is the fundamental adhesive utilized in the assembling of wood composites, with an expected yearly utilization of roughly 11 million tons around the world, followed by melamine and phenolic adhesive. The domination of urea formaldehyde adhesive is because of their excellent adhesion properties, high reactivity, short press time, low curing temperatures, relatively low cost, and ease of handling. The formaldehyde emission from wood-based panel can lead to indoor air pollution that can be spread through the ceiling, storage, floor, furniture, wall, etc. Formaldehyde emission from the board is known as one of the primary elements for causing a sick building syndrome and is the most part connected with unfavorable human medical conditions such as nausea, skin sensitization, genotoxicity, respiratory irritation, leukemia, and nasopharyngeal cancer. The objective of This research is to prepare an ultra-low molar ratio urea formaldehyde adhesive at 0.f per U mole ratio, and the second to do post-modification of ultra-low molar ratio urea formaldehyde adhesive by mixing with different types of organic acids such as acetic acid, malic acid, and citric acid. And third, to characterize the basic and chemical properties of the adhesive and their application according to the Japanese Agricultural Standard number 233. The ultra-low molar ratio urea formaldehyde adhesive was prepared using an addition condensation reaction with 37% purity formalin and 99% purity urea granules. The pH was adjusted to around 8 and the temperature
Recording in progress.
40 degrees, subsequently raised to 90 degrees and kept stable for 1 hour. Afterward, the pH was adjusted to around 5 using formic acid and the temperature was set to 80 degrees for condensation reaction until reaching a target viscosity. Second urea was added to prepare a 0.8 F per U mole ratio. The temperature was set around 27 degrees and the pH was adjusted to 8 using sodium hydroxide. The adhesive was kept for 24 hours before examination. The post-modification of ultra-low molar ratio urea formaldehyde adhesive was done before the application as a plywood adhesive performed by mixing acetic acid, malic acid, and citric acid, utilized as the organic acid hardener at 3% level based on the theoretical solid content of urea formaldehyde adhesive, and ammonium chloride was utilized as a control hardener. The basic properties of control and modified urea formaldehyde adhesive were determined, such as solid content, gelation time, acidity, viscosity, and free formaldehyde content using oven dry way method, gelation time meter, pH meter, rotational rheometer.
Recording stopped.
The functional group of liquid and cured adhesive were scanned using reflectance infrared spectroscopy from 4,000 to 400 per centimeter. A plywood was fabricated from rubber wood veneer, hot pressed at 140 degrees with 0.8 megapascal for 4 minutes. Tensile strength and formaldehyde emission were assessed based on Japanese Agriculture Standard number 233 using a universal testing machine and UV spectrophotometer. The addition of organic acid decreased the pH of urea formaldehyde adhesive control, which has a value of 8.1. The citric acid has 3 carboxylic groups, resulting in lowest of pH of 6.3, whereas the malic acid and acetic acid, which have 2 and 1 carboxylic group, decrease the pH respectively to 6.9 and 6.8. The addition of organic acid slightly decreased the solid content of the control urea formaldehyde resin, which have a value of 62.3%. The addition of citric acid decreased solid content by 3.5% to around 60%, whereas acetic acid and malic acid decreased the solid content by about 3%. Citric acid has more organic volatile compounds, therefore decrease in solid content. The viscosity of urea formaldehyde adhesive was reduced up to 12%. The lowest viscosity, 196 centipoise, was obtained by adding 3% citric acid. It caused a decrease in the interfacial tension of urea formaldehyde resin, so that the flowability, transfer, penetrating, and wet the glue particle is increased, and the adhesive strength is increased. The gelation time of urea formaldehyde adhesive control was 220.5 seconds. The addition of citric acid into adhesive declined the gelation time by up to 16%, as well as the addition of acetic acid and malic acid which also affect reducing the gelation time of urea formaldehyde resin by 5% and 8%. The addition of citric acid with 3-carboxylic group can decrease the free formaldehyde content in the urea formaldehyde adhesive so that it can reduce the value of urea formaldehyde adhesive control from 0.25% to 0.20% and eventually decrease the formaldehyde emission. The addition of malic acid and acetic acid reduced the free formaldehyde content to 0.22 and 0.23% respectively. Regardless of the type and level of organic acids, the functional group of liquid ultra-low molar ratio urea formaldehyde adhesive mixed with different types of organic acids were built of the NH2, CO, CH, and H of primary amide at a wave number of 3310, 2960, 1635, and 1600 per centimeter respectively. No spectral differences were found for the modified liquid urea formaldehyde adhesive compared to the control. After curing, the functional group altered slightly owing to the formation of a three-dimensional network from the reaction of urea formaldehyde adhesive and the hardener. The intensity of the functional group was markedly reduced after curing. The NH2 at 3310 per centimeter was still detected with smaller intensity compared to the liquid adhesive. The CH, CO, and NH of primary amide were slightly moved to the wave number of 2900, 1607, and 1550 per centimeter respectively after the curing process. Theoretically, the carboxylic of organic acid can react with the free formaldehyde and the methylyl group to form a cross-linked polymer of ultra-low molar ratio of urea formaldehyde adhesive. This probably altered the functional group of urea formaldehyde adhesive after curing. The addition of 3% level of citric acid enhanced the tensile shear strength of plywood from 0.94 megapascal to 1.08 megapascal. There was no remarkable difference in value between control and modified urea formaldehyde adhesive with 3% level of acetic acid and malic acid. Based on Japanese agriculture standard, the minimum requirement for interior application is 0.7 megapascal. The formaldehyde emission value of urea formaldehyde bonded plywood were similar to the trend of tensile shear strength. Statistical analysis reveals that the addition of 3% level of citric acid reduced the formaldehyde emission of plywood from 0.57 milligram per liter to 0.31 milligram per liter, and no remarkable difference between control and modified urea formaldehyde with a 3% level of acetic acid. According to the Japanese agriculture standard, control and modified ultra-low molar ratio urea formaldehyde adhesive will meet the minimum requirement of F3 star and even an F4 star with maximum 0.4 milligram per liter for modified 3% citric acid. The conclusion of this research is the ultra-low molar ratio urea formaldehyde adhesive at 0.8 F per U mole ratio was successfully prepared. The addition of organic acid enhanced the reactivity of the ultra-low molar ratio urea formaldehyde adhesive via separation of carboxylic acid group and methylyl group of the free formaldehyde. The incorporation of 3% citric acid results in the lowest content, viscosity, gelation time, pH, free formaldehyde content, and formaldehyde emission, otherwise improving tensile shear strength value of plywood, showing that 3% citric acid could be added as a hardener of urea formaldehyde adhesive. This research project was supported by PT Grini Alam Indonesia titled Penelitian dan Pengembangan Perekat Lamah Lingkungan untuk Produk Panel Komposit Non-Kayu Berbasis Limbah Pelepah Pinang. Thank you for your kindly attention.
Thank you, Mr. Raden, for the very interesting presentation. And this is the end of presentation session, and now we can start our third Q&A session. However, unfortunately, we are about 18 minutes behind the schedule, so I have to cut our Q&A session from 10 minutes to only 5 minutes. Okay, to all presenters and participants in this room, I invite you to turn on your camera so we can have an interactive discussion. And for anyone who wants to ask question, please kindly raise your hand, or you can write your question in the chat room. Now I will check in the chat room. Okay, there are already 2 questions for Professor Adi. The first one is from Ms. Dia. According to your result, the best formulation of bioadhesive was 2.5 per 10, and it was applied on laminated Sengon wood and resulted satisfyingly. I wonder if you use for laminated bamboo, is the same formula will give the optimum result, considering bamboo has stronger physical mechanical properties. Thank you. And the second question for Professor Adi is from Mr. Adli. Mr. Adli asked that why the solid content of the adhesive is very low. It means around 90% are volatile solvents. Is it feasible for wood adhesive application? Thank you. Now, Professor Adi, you can start answering the question, please. Thank you.
Okay. Thank you, Ms. Karina. Thank you for question
Recording in progress.
Of the Mr. Yahya. That I think the possibility could be the same of the formula, but to be sure, you need exponent 8. Okay. And to Mr. Adi, based on experience of the research, I found one of the properties of the adhesive of the tannin are generally in the range of 10 to 20%. Never more than 20 or 30. I think this is especially of the tannin adhesive. Okay, maybe enough.
Thank you for Professor Adi for answering the question. Is it enough for Mr. Adli and Ms. Dia? Is the answer satisfactory?
Yeah, Mr. Alina, it's okay. Thank you very much. Thank you, Prof. Adi.
Okay.
Thank you. Due to the limitation of our time, maybe one question more. Is there any question more? Okay. There isn't. Then I would like to ask Mr. Esa. Are you with me? Mr. Esa?
Yes.
Okay.
Miss Karina.
I think your research is very comprehensive because you not only analyze the noodle properties, but also analyze its production cost. My question is, how about the demand of this this healthy noodle in the Indonesian market? Have you studied it yet? Thank you.
Erlina, based on literature study that we read that the demand of healthy food nowadays increase in 3 years. 3 years from 2018 to 2021. However, in the market, we still rare found about this product. So we just try to this. Thank you.
Okay, thank you, Mr. Esa, for answering my question. And now, let's move to the fourth presentation session. Once again, I would like to thank all the presenters in the session for their very insightful and interesting presentation. Okay, in the fourth presentation session, we will have another 5 great presenter from BRIN, started from Dr. Sukma Suryakusuma, and then Dr. Afni Restasari, Mrs. Woro Setia Boma, Dr. Imran Arat Sofianto, and the final presenter is Professor Tati Husniati. Okay, let's introduce our first presenter for this fourth session. The first presenter is Dr. Sukma Suryakusuma. Dr. Sukma Suryakusuma is researcher at National Research and Innovation Agency. He graduated from Kyoto University, and his current research are mainly on the durability of sorghum bagasse particle board against termite and decay. Okay, to the IT team, please play Dr. Sukma presentation, please.
Hello everyone, my name is Sukma Suryakusuma. I am from the National Research and Innovation Agency of Republic of Indonesia. Today I would like to talk about the research result from my student Jajang Sutiawan, with the title is Termite and Decay Resistance of Tree Sorghum Accession Particle Board Bonded with Malic Acid. So, previously, we already obtained the good quality of the particle board from the sorghum bagasse bonded with the malic acid. But we still don't know about the termite and fungi resistance of the particle board. So that's why our objective of this study is to know about the biodeterioration of the particle board against termite and fungi. So we use the sorghum bagasse with the 3 accession. Those are a Pahat, Super 1, and 4183A accession. And also we use the malic acid adhesive as the binder. And here we prepare the sorghum bagasse from the stalk of the sorghum using the drum chipper and also the ring pickle to make the more small of the particle size, and we sieve the particle to obtain the particle size retained in the sticky mesh. And then we dry the particle using the open dry at 60 degrees C to obtain the moisture content less than the 5%. And also we prepare the malic acid solution as the binder with the solid content is 44%. And here is the particle board manufacturing step. The first step, we mix the particle with the adhesive in the blender, and then we dry it with the oven dry at 80 degrees C for 12 hours. After that, we make the mat forming using the forming block with the size is 30 by 30 centimeter, and then we press the mat using the hot pressing machine at 200 degrees C for 10 minutes, and then continue for the conditioning for 7 days. And after 7 days, we test the particle board for the biodeterioration. The first is for the termite resistant test. According to the Indonesian National Standard 7207/2014 to note the weight loss and the mortality. And the second test is for the decay resistance. We refer to the Japanese standard, that is the GISK 1571. From the research result, we can see here that the mortality of the termite in the particle board sample more higher than the control. Also, from the weight loss percentage weight loss of the sample, we can see here that the particle board sample have a lower weight loss than the control. This means that the particle board have the good durability against the termite. And also here we can see that the particle board using the sorghum bagasse has the weight loss degraded by the white rod or brown rod lower than the control. This indicated that the particle board has the good durability against the decay. So, from the research result, we can conclude that the weight loss of particle board bonded with malic acid against termite attack was lower than the control. In addition, control sample had a higher weight loss than particle board bonded with the malic acid after 12 weeks of brown rot and white rot fungi attacks. And sorghum accession had no significant effect on termite and decay resistance due to the chemical components of the three sorghum accession used to have uniform chemical component. That's my presentation. Thank you very much for your kind attention.
Okay, thank you, Dr. Sukma, for the very informative presentation. Now we move to the second presenter. We have Mrs. Afni Restasari. Mrs. Afni is a researcher in the Research Center for Biomass and Bioproducts and a PhD student in Queen Mary University of London. Her current research is mainly on polymer composite materials. Okay, to the IT team, please play Mrs. Afni video.
Thank you for the opportunity. Today I'd like to present our research on preliminary study of effect of polymer secondary plasticizer on flow behavior of hydroxyl perminated polybutadiene or HTPB. CSP or composite solid propellant consists of 70 until 90% of solid particles, therefore the processability is important. It is determined by its liquid contents. hydroxyl terminated polybutadiene, and toluene deisocyanate or TDI. To improve it, plasticizer is required. DOA or dioctyl adipat has been used as plasticizer for CSP. It is proven to decrease viscosity and extend port life of CSP. However, DOA increases flow index of CSP. It can be bad for the quality of CSP. For example, here we can see the void inside the CSP, and it causes damage when it is burned. Therefore, the finding new plasticizer is required. Based on Hansen solubility parameter, palm oil are hypothesized to be compatible to STPP as plasticizer. It is because STPP, palm oil, and DOA have similar HSP values. Therefore, the objective of this work is to investigate effect of palm oil DOA plasticizers on flow behavior of STPP. The method includes mixing STPP, DOA, and palm oil with this ratio, and then viscosity measurement using viscometer Brookfield at various rate and various temperature. After that, we plot the graph to the equation 1 and 2 to get the flow index N and molar volume V. Here are the results. So with plasticizer, viscosity of STPP decreased until 62.5%, but however, addition of palm oil in decreasing viscosity is not too significant. On the other side, on flow index, as we have known that the DOA will increase the flow index, and surprisingly, addition of palm oil decreased the flow index until 7.6%. Here are the curves from temperature effects. From the curves, we got a very strong correlation level so that we can determine the flow index. First, the temperature effects on viscosity. Increasing temperature decreases viscosity of STPP, DOA, and palm oil. And second, for flow index, we can see here that the flow index of STPP, DOA, and palm oil is lower than STPP and STPP, DOA. The origin can come from the palm oil. For example, here palmitic acid have less oxygen atoms than DOA. Therefore, it builds less hydrogen bonds with STPP. And here is we got the molar volume, which is similar to STPP TDI in beginning of polymerization. The conclusion: unlike the using of DOA alone, which increased flow index of STPP, palm oil DOA successfully decreases the flow index of STPP. Molar volume of STPP palm oil DOA is similar to STPP TDI, promising compatibility in binder system of CSP. That's all from me. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mrs. Afni, for the informative presentation. And then we have Mrs. Woro Setiaboma as the third presenter. Mrs. Woro Setiaboma is a researcher from the Research Center of Process and Technology. She got her master's degree from Universitas Gadjah Mada, and her current research are mainly on characterization of protein plant-based flowers and development product. To the IT team, please play Mrs. Woro presentation. Thank you.
Good afternoon, everyone. My name is Woro Setiaboma. I am a researcher from Research Center of Food Processing and Technology, and here I would like to present that about my study. The title is Cacao Cell, Optimization of Carboxyl Methyl Cellulose Using Response Surface Methodology. This is the content of my presentation, and the first is introduction. cacao industry contribute value in Indonesia has been a famous plantation, hence the production of cacao of Indonesia ranked third in the world. Based on BPS statistic of Indonesia, the cacao bean crop more than 700,000 tons in 2020. As we know that cacao cell, one of a byproduct in this industry, and it contain not only fiber but also cellulose. And as we know, the cellulose is a polysaccharide through its insoluble in water. And then the applying of cellulose is more value synthesis being carboxyl methylcellulose or methylcellulose or hydropropyl methyl cellulose. CMC is derived by synthesis of cellulose that should be soluble in water and should apply in the industry, mostly in food industry. It has some functions such as thickener, stabilizer, emulsifier, or gel agent. The synthesis of cellulose to be CMC, where it's changed cellulose to be of alkali cellulose that's swollen in aqueous NaOH and excess organic solvent with monochloroacetic acid and its sodium salt. The properties of CMC depend on the degree of substitution that FAO state the standard of DS not less than 0.2, no more than 1.5. This CMC process is designed with an optimization using RSM, response surface methodology, in central composite design, so it can control process condition to produce CMC with DS value that range from standard in food industry. Hence, the aims of this study was to determine the influence of addition natrium monochloroacetic acid, sodium hydroxide, and temperature of CMC using response surface methodology. Let's move to material and method. The first is about materials. The materials, cacao shell, what was obtained from Indonesia Coffee and Cacao Research Institute, Jember, and then it was isolated the cellulose using Ferdiansa et al. And after obtain the cellulose, it's synthesis by method Adinugraha et al. The optimization targeted was a degree of substitution value that is measuring measured using titration method of standard test method from CMC, and then the best or the suggestion predicted by RSM was assay moisture content, purity, solubility, pH, FTIR, and XRD. The statistical analysis of this research using RSM data were conducted by design experts 7 trial, and the analysis of interaction of addition sodium hydroxide, natrium monochloroacetic acid, and temperature using ANOVA. Let's move to the result and discussion. The first is result about optimization. In this figure, the response surface analysis of the data demonstrated of relationship between synthesis condition and degree of substitution value, and it had a cubic model. Furthermore, the value lack of fit model was not significantly different, and adequate precision was 15.7, and it higher than 4. The previous studies said that this lack of fit and adequate precision was good value. And based on this model, the model DS was expressed in the variable mathematical in an equation. And in this equation, perform that both addition natrium monochloroacetic acid and sodium oxide had positive linear effect, while the temperature was a negative linear effect. The data performed that increasing both natrium monochloroacetic acid and sodium hydroxide went up the DS value. There was positive interaction between NOH and natrium monochloroacetic acid. and monochloroacetic acid and temperature, while the interaction between sodium hydroxide and temperature was negative. It's indicated that increasing temperature will drop the DS value even if the additional sodium hydroxide was high due to degradation, cell loss, and glycolate formation. And then based on the model equation predicted, the RSM recommended to conduct it in this condition, and we had actual value of DS was 0.79, and the DS value of the predicted by RSM was 0.75 with one of the stability value. Therefore, it was concluded that the development model could accurately predicted by DS value because the result indicate error was less than 0.05%. The characterization of the best condition of RSM that we obtained was compared with the commercial. Either the DS or moisture of the CMC cacao cell was lower than the commercial, though it has range in CMC standard Picodex. This is the figure of infrared spectra of CMC, cellulose, and CMC commercial by sigma. The first, it's in differences in OH or hydroxyl group that's seen in the cellulose. The OH group is weaker than OH of CMC. The OH group of the CMC had been reduced because they were substituted by natrium monochloroacetic acid. The second difference is in the wave number of 1,600 and 1,1400, which was only seen clearly in CMC. The CO double bond and CH2 scissoring. The increasing carboxyl group and methyl group in CMC was confirmed successfully synthesis to be carboxyl methyl cellulose due to hydroxyl group of had substitute on cellulose. And comparing spectrum of CMC cacao and the commercial, there is similarity characterization of both. And then this is the result of XRD patterns of CMC and cellulose. It's seen that cellulose cacao cell had crystallinity intensity in 22, 34, and 17. While the CMC, the high intensity had 9.6 and 21.18. The CMC had decreased crystallinity due to the cliff of hydrogen bond by substitution at hydrogen group in cellulose. And this research showed that the synthesis of cellulose was successfully done to be a CMC. The conclusion of this study, the first optimization of CMC synthesis was designed using RSM, and the results show that the DS increased in line with addition natrium monochloroacetic acid and sodium hydroxide, and its positive effect on the DS. The optimum condition of synthesis was suggested in this condition, and the verification of in this condition had DS value was 0.79, and it had moisture content, purity, and pH addition was in range in standard coded, and it was successfully achieved from cellulose from cacao cell, proved that by FTIR and XRD. Thank you very much for your attention, and that's all.
Okay, thank you for IT team and for Mrs. Woro for the insightful presentation. We now move to the fourth presenter. We got Dr. Imran Aratsofianto. Dr. Imran is a research scientist at Research Center for Biomass and Bioproducts. His doctoral degree was obtained from Nagoya University, Japan, and his research interest is mainly on the application of near-infrared spectroscopy for wood and agricultural products. Okay, to the IT team, please help me to play Dr. Imran presentation.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Imran Aratsofianto from Research Center for Biomass and Bioproducts BRIN. I will present research from my team with the title Application of Near-Infrared Spectroscopy for Predicting Changes of Water Content and Green Color of Red Delicious Washington Apple in Room Temperature Storage. Freshness and green color of an apple are two criteria for people to buy apples for consumption. Freshness is always associated with water content, while green color is associated with taste. The industry should understand the factors affecting freshness and green color of an apple. Rotten process of an apple affected the changes of water content and green color. For real, not all Indonesian families have a refrigerator for storing apple to minimize the rotting process. Many families only store the apples in an open air of dining table as of room temperature. Near-infrared spectroscopy using NIR light electromagnetic waves range from 800 to 2500 nanometer have been used to measure organic materials such as agricultural products. As one of non-destructive testing, this method is more objective to be applied to predict the changes of water content and green color of an apple. Organic materials such as apple containing hydrogen from water content will have a measurable NIR spectrum. Then, this research applied near-infrared spectroscopy to make prediction model on the changes of water content and green color of the apple. The objective of this research is to make prediction model using near-infrared spectroscopy on the changes of water content and green color of the apples, which were stored in an open air of room temperature. 30 red delicious Washington apples bought from supermarket serve as research materials. This kind of apples is imported from the USA. The apples were weighed using digital scale immediately after bought. The initial weight were between 140 to 160 grams. The samples were stored in an open air of room temperature for 2 months. Weight of 30 air dry apples in gram were measured 6 times within 2 months. At the end, the apples were often dried in an oven with temperature of 102 plus minus 3 degrees Celsius to obtain oven dry weight. Water content in percent is calculated by air dry weight reduced with oven dry weight, then divided by air dry weight multiplied with 100. Color reader was used to measure the green color of the apple samples simultaneously during weight measurement. Color measurements were conducted in 2 places of the apple. The data obtained are CIE-LAB coordinates. L is the lightness, A is red-green coordinate, and B is yellow-blue coordinate. The total difference symbolized as delta E is calculated with this formula. The changes of water content and green color were observed from the first measurement as subtraction value. Thus, there were 5 changes data from 6 measurements for water content and green color of the apples. Total data for changes of water content and green color used were 288 for each. Then these data were combined with their NIR spectra data for analysis. NIR spectra measurements were conducted at the same position for RIN color measurements using Perkin-Elmer FT NIR spectrometer. NIR spectra of the apples in absorbance values were acquired in the wavelength range of 700 to 2500 nanometer in resolution of 16 per centimeter and 32 scan. The conventionally data laboratory served as Y data, and their NIR spectra data served as X data, were combined for further analysis. Cross-validation partial least square regression, or CVP-LSR, was used to obtain the best prediction model. An effective wavelength range was selected from 700 to 900 nanometer. Reprocessing spectra such as standard normal variate, multiple scatter correction, first and second derivative with 19 smoothing point were applied for analysis. The best prediction model was considered from the highest value of the coefficient of determination for cross-validation, R²CV, followed by the lowest value of the root mean square error for cross-validation, or RMSECV. Result and discussion. Water content data for 30 apple samples for 2 months research provide minimum, maximum, mean, and standard deviation values of 85.3, 95.3, 90.2, and 2.80% respectively. RIN color data of the apple samples provide mean LAB values of L 35.1, A 19.1, B 8.4 for 2 months measurement. As for 2 months of the changes of water content and RIN color of the apple samples, they were resulted by the subtraction from the first to the 6th measurement of the water content and RIN color data. Their mean values are 0.8% and 5.9 respectively, which are very small within 2 months for open air room temperature storage. This is the original NIR spectra of the apple samples within 2 months measurement. The absorbance value was in the range of 0.3 to 1. The reason of choosing the wavelength range of 700 to 900 nanometer was that this range resulted better prediction on the changes of water content and RIN color of the apples. It is a shorter wavelength range compared to the research using wood materials. These are the results for many prediction models from many types of NIR spectra used. The best prediction model for changes of water content and RIN color resulted from their original spectra data. The R²CV values were 0.72 and 0.42 for changes of water content and RIN color respectively. The correlated RMSECV values were 0.16% and 1.89 from the optimum number of LV8 and 6 respectively. These are the scatter plots of the measured and predicted for changes of water content and RIN color. Previous research by Kusumiati et al. 2021 used wavelength range from 702 to 1065 nanometer to predict water content of apple samples, resulted R² prediction of 0.61 using PLSR analysis. This present research resulted higher R²CV value of 0.72 than the previous. The conclusion of this research are the apple stored in room temperature for 2 months in Cibinong in early February to end of March 2022 are still fresh and edible with high quality. The changes of water content and RIN color were very small, 0.8% and 5.9 respectively. Average water loss for 2 months for the apples was very low, 1.5%. The apples after 2 months storage are lighter, redder and yellower. Prediction model on the changes of water content and green color resulted R-square CV of 0.72 and 0.42 respectively from the original spectra data. And IR spectroscopy is more precise to predict water than color of organic materials. Thank you. Terima kasih.
Thank you, Dr. Imran, for the very interesting presentation, and thank you for the IT team too. And for our final presenter, we have Professor Tati Husniati. Professor Tati Husniati is a research professor at Research Center for Applied Microbiology. She graduated from Hokkaido University, Japan, and Professor Tati current research are mainly on the role of microorganism and enzyme in various food products. To the IT team, please play Professor Tati presentation. Thank you.
Good afternoon, everybody. I would like to present our research result, protease stability of indigenous Lactobacillus subsumensis AN3832 and Fructobacillus fructosus AN1720 at cold and freezing temperature. Recently, the application of enzyme in industry has grown rapidly. Enzyme technology is an alternative to replace various chemical processes in industry. Proteases are one of the most important commercial enzyme groups due to their wide application in various industries. Enzyme import can be reduced by exploring the potential of enzyme from local bacteria. Proteases can be isolated from various sources such as plant, animal, and microorganisms. One of the potential protease-producing microorganisms is lactic acid bacteria. Lactic acid bacteria is a safe bacteria because it includes generally recognized as safe. Protease is a protein that can be damaged by various factors and stress during storage such as pH, ionic strength, redox potential, and temperature. Proper handling and storage of protease can help maintain the catalytic activity of protease. According to a research report on Microbiology Division, Research Center for Biology, kanal BRIN, Lactobacillus subsumensis and Fructobacillus fructosus are lactic acid bacteria that can produce protease based on qualitative and quantitative tests. The protease Lactobacillus subsumensis had optimum activity at 40 degrees Celsius pH 7, while protease Fructobacillus fructosus optimum activity at 45 degrees Celsius pH 6. However, the protease stability of the two lactic acid bacteria at various temperature and time storage is not known. Therefore, the study focused on determining the stability of the protease L. subsumensis and Fructobacillus fructosus at various temperature and storage time. The method subculture of Lactobacillus subsumensis and Fructobacillus fructosus by using solid and liquid MNS media. Protease production from Lactobacillus subsumensis and Fructobacillus fructosus by using SARMA and D method. 2% of its Lactobacillus subsumensis and Fructobacillus fructosus inoculated into 250 ml of nutrient-proof media with 1% casein, incubated 48 hours 37 degrees Celsius, centrifuged 8,000 RPM, 10 minutes at 4 degrees Celsius, and then supernatant was taken. Protease activity of Lactobacillus subsumensis and Fructobacillus fructosus by using Horikoshi method. One protease unit is defined as the number of milliliter of protease required to produce 1 micromole of tyrosine per minute with casein as the substrate. Protease activity concentration tyrosine divided MR tyrosine cross volume total volume divided volume enzyme cross reaction time cross dilution factor. Stability of protease Lactobacillus subsumensis and Fructobacillus fructosus at various temperature and storage time. The relative protease activity was the percentage of activity of particular protease unit divided by the activity of the highest protease unit multiplied across 100%. The data was analyzed by statistical analysis, a completely randomized design, ANOVA, by using MITEP 17 software and 2K tests. The results show that Table 1, activity of the protease from Lactobacillus cestumensis AN3832 at various temperature and storage time. Storage time from 7 up to 28 days, protease activity unit per milliliter, and protease relative activity in percentage. The results show that percentage of relative activity from protease Lactobacillus cestumensis at cold temperature decrease with increasing the storage of time. The highest percentage of relative activity of the protease Lactobacillus cestumensis was obtained at 7 days of storage, 95%, and the lowest on 28 days of storage by 85%. Table 2 show the activity of protease from Lactobacillus cestumensis at freezing temperature at various storage time from 7 up to 28 days, protease activity in unit per milliliter, protease relative activity in percentage. The result show that the percentage of relative protease activity from Lactobacillus cestumensis AN3832 at freezing temperature decreased with increasing the time of storage. The highest percentage of relative activity from protease Lactobacillus cestumensis was obtained at 7 days of storage with 96%, and the lowest on 28 days of storage with 85%. Table 3 show the activity of protease from Fructobacillus fructosis at cold temperature at various storage time from 7 up to 28 days, protease activity in unit per milliliter, protease activity relative in percentage. The results show that the percentage of relative protease activity from Fructobacillus fructosis at cold temperature decreased with increasing storage time from 7 up to 28 days. The percentage of relative activity from the protease fructosis were highest on the 7th day of storage with 89%, and the lowest and 28 days of storage with 68%. Table 4 show activity of the protease from Fructobacillus fructosis at freezing temperature at various storage time from 7 up to 28 days, protease activity in unit per milliliter, and protease relative activity in percentage. The results show that percentage of relative activity from the protease from Fructobacillus fructosis at freezing temperature decreased until 21 days, then remain constant until 28 days. The highest percentage relative activity of the protease from Fructobacillus fructosis was obtained in 7 days of storage with 98%, and the lowest when on the 21 and 28 days with 95%. So the percentage of relative activity from the protease Lactobacillus cestumensis and Fructobacillus fructosis at cold and frozen temperature decreased with increasing storage time. It was suspected that this was because the protease used was from a solution supernatant Enzyme in solution form was unstable and its rapid activity decreased gradually during storage due to various chemical reactions including hydrolysis, aggregation, and conformational change. The conclusion: the stability of the protease L-sustumensis and Lactobacillus fructosis at 7 up to 28 days of storage were reached at cold and freezing temperature. Protease stability of Lactobacillus sustumensis was better than Lactobacillus fructosis at cold temperature, whereas at freezing temperature it was the opposite based on the protease relative activity. It is recommended to use Lactobacillus sustumensis at cold temperature as a protease source, while at freezing temperature to use Lactobacillus fructosis. Thank you.
Thank you, Professor Tati, for the insightful presentation. And also, I would like to thank all the presenters for this session. Now we will have our Q&A session. Anyone who want to ask question, please kindly raise your hand, or please write your question in the chat box and I'll read it for you. To all presenter and participant in this room, I invite you to turn on your camera so we can have an interactive discussion. Okay, I will check first in the chat box. There is a question from Dr. Saptadi to Mrs. Woro. What is your consideration of using cocoa shell as a raw material? Does cocoa shell cellulose have advantages compared to cellulose from other biomass? As I know, the shell content is more dominated by lignin. Okay, Mr. Woro, Mrs. Woro, maybe you can answer Dr. Saptadi's question.
Thank you very much, Dr. Saptadi. Can you all hear my voice? Because in my place is rainy.
Okay, very clear.
Yes, clear enough.
Very clear.
Okay. The background, I did it because it's have done by my junior, and then my research my research want to prove that the CMC can be synthesis from cacao cell, and yes, as long as you know that the cacao cell is not high cellulose, but it's I want to prove that cacao cell can be synthesis to be CMC. That's all. It's clear, or
okay,
you want to any suggestion?
Yeah. Okay, it's okay.
Okay, thank you for Mrs. Woro for answering the question. Maybe we have another question. Okay, Miss Diayu, you can in your question.
Okay, thank you very much, Miss Lina. I would like to ask to Miss Afni Estasari, are you here? Or maybe if
Yes, I'm here.
Okay, thank you, Miss Afni. I'm very interested with your research. It's very it's very amazing because we know that the DOA is hard to get, right? So you, if I'm not mistaken, maybe you want to replace the use of DOA with palm oil. Am I correct?
Yes, with palm oil.
Oh, okay. So I seen your research title is in preliminary, but I can see that the result is satisfying. So, but I wonder if how the results if you use the HDPB with addition only palm oil without DOA. I'm just thinking because you just your research result is only using DOA and palm oil, but not HTPB with palm oil only. So I wonder how if it use palm oil without DOA. So please, maybe you have tried it.
Okay, thank you for your advice and question. So before this research, we have tried the palm oil and the STPP only. However, the plasticity or the flow index is not too good. Therefore, in this research, we plan DOA and the palm oil. Thank you.
Okay, so that's why in your title you use the palm oil as the secondary. So, is it possible in the future is palm oil will be the primary plasticizer?
The reason is in the title secondary because we plan the palm oil and DOA, and because we have tried to use palm oil only and the result is not so good. I think in the future we just blend the DOA and the palm oil with a several ratio.
All right.
Or maybe we can try the other vegetable oil or sunflower maybe.
All right. Thank you very much. I'm just wondering because you used the title preliminary, so I am curious with your further research.
Okay,
thank you very much.
you.
Congratulations for you and for your team.
Okay.
Thank you, Ms. Dia and Mrs. Afni. Are there any more questions? Maybe we still have about 3 minutes, maybe. For anyone who want to ask a question, you can raise your hand or write in the chat box. Is there any question? Okay, if there isn't, I would like to ask to the first presenter of this session, Dr. Sukma, or maybe his team can answer my question. Are his team here?
I am Jajang Setiawan, present to Dr. Sukma.
Okay, I want to ask, Dr. Sukma explained in the presentation that the increase of durability with malic acid adhesive is due to its acidity. I want to ask, is there any possibility that malic acid contain maybe harmful substance to termite or fungi besides their acidity that can cause the increase in durability? Thank you.
Thank you very much, Ms. Liana, for the question. The increased resistance to decay is probably due to high acidity. The acidity of malic acid lower than 2, and then the acidity potential to resistant durability against termite and decay. In addition, the moisture content sorghum bagasse particle bond with malic acid less than 10%. Compared to phenol formaldehyde and urea formaldehyde, particle bond with malic acid less moisture content. Less moisture content potential to durability against termite and decay, Mr. Erliana.
Okay, thank you for answering my question, Mr. Jajang. And is there any more question you can ask? I think we still have 2 minutes maybe for one question. Okay, if there isn't anyone who want to ask question, I will ask to Mr. Imran, Dr. Imran.
Yes, please.
Yes, you use NIR to predict rain and water content. I want to ask, is there any weakness or an advantages to use NIR to predict this properties, this rain and water content? Thank you.
Yes. This is NIR spectroscopy is one of non-destructive measurement. Yeah. If this is our preliminary study, so we want to use it to be applied in industries, such as we use this NIR to be a inline process. So the apple is on the online, and we emit the NIR light, so we can predict the water content, the sugar for the obvious measurement is a sugar, yeah. But in this research is water content first, because so the industry can predict the how long the NIR is still fresh. So the supermarket, for example, can write down the data of the NIR measurement in the supermarket, that this is it is better to eat before 2 months, for example, like that. So this is a non-destructive measurement, and it is quick measurement, like that.
Okay, thank you, Dr. Imran, for answering my question. Maybe I will give one more chance to you. Are there still any question? There isn't? Okay, I think this is the end of our session. Thank you very much for the presenters for the very interesting and insightful presentation, and also to the other presenter to give your questions to make this session more interactive. Okay, I want to inform you that we will have the closing remark from Mr. Dawam as the head of Research Center for Biomass and Bioproduct in the main room, and we also have announcement for the best presenter. So please stay tuned in our ICONLIG event until the end. Once again, thank you for the participation in this seminar. And before we go to the main room, let's have the photo session. To Miss Ayu, please help to lead the photo session. Thank you.
Okay. I know it's already noon, but I hope you are still have your smile. Okay, please. We have 2 pages here, and I will count to 3 for the first page. All right, please turn on your camera. Okay, for the first page, I'll count to 3. 1, 2, 3. All right. Wait, hold on. Next, the second page, smile. 1, 2, 3. All right, thank you. I'm done, Miss Elena.
Okay, thank you, Miss Ayu. I think we can go to the main room. I want to apologize if there is any weakness in my act as moderator in this session. Thank you very much for your participation, and see you again in the next ICONLIG. Thank you very much.
Okay, for everyone, please go back to the main room. Click on leave room. Do not leave meeting, okay? I will give you a gentle reminder. Please click the leave room, not the leave meeting. I insist. Thank you very much.
Thank you very much.
Recording stopped. Recording in progress.
Sekarang yang terjadi, terobosan itu menjadi mungkin oleh yang namanya, saya ulang, oleh yang namanya ilmu pengetahuan, oleh yang namanya teknologi, oleh yang namanya inovasi.
In 2020, Indonesia entered a new national development era. On this term, President Joko Widodo administration turned its focus on developing Indonesia's human capital and mastery of science and technology through Indonesia's national research priorities. The quality of a country's research and innovation is a national asset. As a key step, the government issued Law No. 11/2019 on the National System of Science and Technology, or the Sisnas Iptek Law. By issuing the law, the government of Indonesia was signaling more attention to and commitment for the growth of the research and innovation during the next phase of Indonesia's development. 9 research fields are listed as the focus fields of Indonesia's 2017-2045 National Research Master Plan. Food, energy, health, transportation, engineered products, defense and security, maritime, social, humanities, and other research fields. These are expected to be able to produce innovative products. In order to address institutional problems of fragmentation among government institutions and the inefficiency of the budget allocation, the National Research and Innovation Agency, or BRIN, was established in 2019 with the Presidential Regulation No. 74 of 2019 on the National Research and Innovation Agency. The President has tasked BRIN to ensure that research and development activities in the country could attract more investments to its science and technology sectors, integrating research and innovation resources, creating and open a collaborative global standard research ecosystem, and creating the foundation of a strong and sustained research and innovation-based economy are 3 directions of BRIN. The contribution of research and innovation to produce a variety of solutions can resolve the challenges faced by the government, industry, and society.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation No. 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Kehidupan manusia bergantung pada tanah, sama seperti kita bergantung pada laut untuk bahan makanan dan mata pencarian. Tumbuhan menyediakan 80% bahan makanan untuk manusia, dan kita bergantung pada pertanian sebagai sumber penting perekonomian dan alat pembangunan. Hutan meliputi 30% permukaan bumi dan merupakan habitat bagi jutaan spesies, serta menjadi sumber air dan udara bersih, dan juga sangat penting untuk melawan perubahan iklim. Indonesia dikenal sebagai negara mega biodiversitas. Dilewati garis zamrud khatulistiwa dan iklim tropis yang menghangatkan dan pepohonan yang menjulang tinggi dan tumbuh besar di hutan. Indonesia menghasilkan variasi genetik yang sangat melimpah, baik dari tumbuhan, hewan, dan mikroorganisme. Dan ekosistem lainnya adalah satu dari 17 tujuan global yang tersusun dalam Agenda Pembangunan Berkelanjutan 2030. Pembangunan berkelanjutan atau Sustainable Development Goals berusaha melindungi, merestorasi, dan meningkatkan pemanfaatan berkelanjutan ekosistem daratan, mengelola hutan secara lestari, menghentikan penggurunan, memulihkan degradasi lahan, serta menghentikan kehilangan keanekaragaman hayati. Biodiversitas Indonesia menjadi aset jangka panjang yang perlu terus dipelajari, dikaji, dan diteliti untuk kesejahteraan bangsa. Badan Riset dan Inovasi Nasional atau BRIN tidak hanya memiliki para periset unggul, tetapi juga fasilitas-fasilitas riset dan berbagai aktivitas riset untuk menghasilkan riset yang bermanfaat bagi rakyat Indonesia. BRIN memiliki berbagai laboratorium, seperti Laboratorium Analitik dan Mutu, Laboratorium Biosafety, Ruang Bersih, Laboratorium Klinis dan Medis, Laboratorium Inkubator, Laboratorium Produksi, dan Laboratorium Penelitian dan Pengembangan yang tersebar di beberapa daerah. Memiliki laboratorium alam, di mana setiap lokasinya memiliki karakternya masing-masing. BRIN mengelola 5 kebun raya dan membina lebih dari 37 kebun raya daerah yang dikelola pemerintah daerah dan 3 kebun raya daerah yang dikelola perguruan tinggi yang tersebar di 23 provinsi. Perjalanan ekspedisi dan eksplorasi terus dilakukan oleh para periset Indonesia untuk mengeksplorasi keanekaragaman hayati ke seluruh penjuru Nusantara.
Good afternoon, ladies and gentlemen. Thank you for staying with us until this closing ceremony. Okay, thank you for joining back in main room and not leaving this meeting. Before we begin our closing ceremony, let me once again to address our big appreciation for all the stakeholders who give their big support for this event. Firstly, from GSPS Bangkok Office and GII. Thank you, Professor Wahyu Duyanto, and also to all our honorable keynote speakers, invited speakers, presenters, and all participants for sharing and supporting in this event. And for the start, ladies and gentlemen, before we announce the outstanding paper and the best presenters, I would like to invite Dr. Akbar Hani Gawam Abdullah as the head of Research Center for Biomass and Bioproducts, National Research and Innovation Agency, BRIN Indonesia, for deliver his closing remark. But due to any condition, he is unable to join us here right now. But we already have his closing remark by video recording. Let's we hear it together. For IT team, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, distinguished guests, ladies and gentlemen. I am Akbar Hanif Dawam Abdullah, Head of Research Center for Biomass and Bioproduct BRIN. It's my honor and pleasure to give the closing remark on the success of second ICONLIG International Conference of Lignocellulose 2022. I believe all of us have obtained fruitful discussion from this conference. I would like to extend my sincere thanks to keynote speaker and invited speaker for delivering such a great presentation, so all of us enlightened by knowledge about sustainable material. Furthermore, I would like to thank all presenters and participants who have joined this conference. I'm sure that every presenter has shared outcomes of research well. I hope through your presentation or discussion afterwards, we can contribute for innovation and economic value for sustainable materials. Finally, I would like to thank all committee who have contributed their best effort in organizing the event, ensuring the success of it. The committee has successfully hosted the event with minimum technical issue. I do hope that the ICONLIG 2022 is able to empower the society through science and technology by innovation. So I would like to apologize for any inconvenience that you might experience during this conference. Thank you for the great contribution and looking forward to seeing you in the ICONLIG next year. Thank you.
All right, thank you very much, Dr. Ahmad Nidawam Abdullah, for the closing remark for the second ICONLIG event. And thank you, ITT, for playing the video. And now, please allow me to announce the results of evaluation for the best presenters and outstanding papers. First, we already have the results for the outstanding papers, which is awarded to 5 chosen papers. This award is given by GAI. And after the objective evaluation, here is the result. Please prepare yourself. The outstanding paper is awarded to 1. Ahmad Shauki with the title of Rapid Test of Bioethanol Raw Material, the Wendell Jason Data Method, Methodification to Fiber Cellulose. Congratulations. Mr. Ahmad Shauki, are you with us? Mr. Ahmad Shauki?